The same thing by stitching various languages. Okay. Even today, last week I was in our Trivandrum office and we have a robot that we built for a hospital. So robot moves around and you can ask questions to the robot, robot answers, that sort of thing. So there is of course a radar which helps it to.
Do you have an actual robot?
Yeah, we built a robot. It's this big actually.
Oh,
so we did 3D printing of its casing and everything, and there's a radar at the bottom. But the AI part, the funny thing is that first we said how do we speak to it? It converts to text, and then it comes back as text. We are not using GPT-4 on any of those things. Okay. Instead, it's using something called Retail AI, which is it's like a wrapper, so it can convert, speech to text. It does exactly the same thing actually. Sorry? Yeah. So speech recognition. So it does convert speech to text, takes the text to GPT, brings it back, and then converts it back to the answer back to speech. So it's exactly the same thing. Now we can say that I'll go multimodal, but why use such a heavy model? We were just trying. It's more like a proof of concept for one particular hospital. We'll see over a period of time. And it's running on Raspberry Pi. You can imagine this. Raspberry Pi is so small, but that's because we have offloaded all the workload to the cloud, and hence we are able to do it. But everything that it does, like navigating in a room and calling this API, everything is on Raspberry, and handling that camera, whatever it is, everything is on Raspberry. Okay. Okay. The second one is that creating video with slides and voice. Now, of course, if you've seen Sora, it can be very easy. But this guy said, I create content on YouTube in Telugu language. And while I'm speaking a motivational video on how to wake up in the morning, I want some pictures to come, which gives morning feeling and walking and running and all that. So it is the same thing, he wrote some prompts, got the story for the whole video, and based on the story, he used diffusion models to create images, and then story got converted into voice, and then used some software to time it, so that voice comes when that picture is coming. All of that.
So number 2 has been replaced with Sora.
Number 2, I hope, from what I've seen in Sora, it's not 100%, but maybe eventually that's right. Yeah.
So you need to do hackathon every month because it gets outdated.
Yeah, that's true. That's true. It's not that old, right? When did we do it? Just a few months back.
3 months back we did a hackathon. Yeah. Most of them are outdated.
Yeah. So this was, if you are a CFO and you want plots out of your data and you don't know what you want, rarely there would be a CFO who doesn't know what he wants, but let's say there is somebody who says that, develop something. Then, what they were doing is that with CSV, they were asking GPT what are the best type of analysis, and then they would ask GPT again to write a code for it, and then send that code and make sure that the code is for Plotly is executed and displayed on your browser.
Yeah.
Right? So in the last one it's speech to translation in language. So
any basic model for the graphical chart analysis and all GPT provides to analysis on the chart?
I haven't seen.
I've heard of something called Graph GPT, but I have never tested it.
I've not tried it. Right?
In fact, that's one of our to-do list in our ImagineView product. How to do a graph read.
Schematic, because last time in the reference you mentioned schematics, because the chemical structure and all those things which you mentioned, I think last that we're facing an issue at client side.
Yeah. I think basic text in a table it can read.
Correct.
But complex graphs, we haven't seen a very robust model.
By graph, you mean the picture
Charts
or
and all, like,
charts? Yeah.
Charts with the data like.
I wouldn't be surprised if it comes. Get this one. Microsoft guys are coming with their own Office Copilot. So it's
moving very
beta,
fast.
It's in beta mode, so it will come anytime. Power BI also does. Okay, you can.
Generation is possible. The reverse is not so much.
Whatever data you have, it suggests the gaps, and that is there.
Reverse is not true.
I'm saying reverse. Based on chart, if you have it, and you make that extract and
There is an energy part actually. There is energy part. There is a language generation part. I think one of the part that you has, I think, is
That is there, so you can type it, what will generate the graph out of it. That is there, the data is there, you type it, you generate the graph and suggest the graph or nothing, reverse the graph, because now you have the PDFs and multiple reports, right? Now you have to make an insight of the inside of that. Right? So that is still, I'm not sure.
Yeah, I've not tried. GPT-4 might do it. Might do
So
it.
the visual interpretation for simple charts like bar, line, simpler plots, you will get it. But if you ask a level 2 question like summary insights from a bar chart, it will fail. It will still give you a number, but the numbers sometimes come up gibberish.
Because at the end, it has to do regression analysis on top of the numbers, right, at the back end.
What it does, what it has to do is kind of insignificant at this point. To your question, the visual interpretation of an LLM, be it multimodal, isn't very strong. It's good enough to answer what this chart is telling, but if you ask for a 10-year bar chart of, let's say, a population health, and ask it to give you average or growth numbers, it will not give you a correct percentage. The interpretation isn't that strong from graphs, but if you augmented the same graph with the data, then it will give you that.
I think in a couple of months we should see that. These big guys are and the researchers are really busy.
Yes,
But which model actually gives you insights out of these old data points? I'm not talking about graphs, but
all of
data
this,
points.
all of this.
Like something like a
GPT-4
quick site. What quick site does is like it will read your dashboard and start giving you insights.
Okay.
Claude,
Is there anything?
Claude will give you, GPT-4 will give you. But you have to give it data, like tabularized data to be able to make sense.
Oh,
If on the third part, which is like CSV part, right? We have a similar use case. It's largely for the media team, the people who are designing programmatic plan, basically campaign plan. So once they see that graph, right, just to answer your question, there is a guy who actually looks at the graph and then he will say, okay, hey, I am seeing this particular problem. Now, can you actually give me a campaign or media plan to address this particular problem? So it gives you the media plan, and then that media plan, then we have written some agents which will actually convert that media plan into actual actionables.
Oh, okay.
But there is a guy who is sitting and seeing that. Person is doing it, but he's just saying, okay, I see a problem here. Can you now rectify this? More as a prompt here.
AI coming in.
Yeah, it will be.
Okay. Okay. Again, this might be a little trivial for some of you who already are in the field, but I just wanted to give you a little bit of historical context of how we are progressing in terms of language and a little bit in images as well. About more than a decade back, we heavily used conditional probabilities because each word, there is a probability that there is a word and after that there's another word, right? There was this conditional probability. So you could use something called naive Bayes where you said that the previous word really doesn't matter. So I'm just taking the probability of that word in the whole page of the corpus. Or you could go a little bit more detailed and say that probability that a word appears after a particular word, there is something, and then based on those probabilities you could make classification, you could make various judgments. It would not do generation for you. Could never do generation. Okay. So this was there, and then after that we moved to something called sequence to sequence model. Okay. So here, when we had these LSTMs or so don't worry so much about the picture. So when you read the words here, right?
noise. Just noise आ रहा है, noise. Some noise is coming. Noise. आवाज आ रही है, आवाज.
सर आपका मेंबर आ रहे हैं, बोले कि 2 बजे हमारा कुछ इवेंट था, तो हम लोग पूछने से आपका कांटेक्ट पर्सन नाम क्या है?
विवेक सिंगल नाम है.
इसलिए हम लोग उनको उधर अभी में बैठाए हैं,
नहीं, यहाँ भेज दीजिए. हाँ, ओके.
Also came late to surprise that we should say that during the course of the talk, the topic upgraded.
Yeah. Okay. So So in old days, when you had probabilities for a word, I would have just one number, right? Probably just one number, and then here you have these dense vectors where you would say that the one word represents 512 numbers. It's a vector, right? So there's effectively more intelligence in it, and which is what we call embedding. You feed the embedding, and then also we had encoder decoder architecture. Google Translate initially was this architecture. It worked quite okay. It wasn't bad really. The problem with this was that it took time, because see the architecture. One word is the system makes some sense out of one word, feeds it to the next one, and feeds it to the next one, which means my context length would never go beyond 128. If you fed really long sentences, you would get bad answers, and it would take considerable amount of time. So that was the problem of LSTMs. But we have deployed systems in production. In our company, they're still working using LSTMs because the problems are such that they are really small. So we are able to, for small emails, we could say whether this is spam or not. What is this email about? Sometimes emails come to help desk, and you want to automatically classify what is this about, and then so that a right person can start looking at it. You don't want a human being to triage an email. So a lot of these problems we solved using these techniques. Okay. Of course, my next slide, maybe you can see what embedding did was that if you were to plot it on a graph, now you can see graph only on 2 dimensions, but let's say if you could, then you would find that similar words were very close to each other on the graph. Yeah, but of course this is far bigger than more than one graph, more than two dimensions. But it did one more thing, which is that this whole thing of embedding creation got hived off from the model. Before that, when you solved a problem at that time, you had to find the numbers for it, whether you call it probability or anything else. When you were inferencing, at that time you had to real time get the probability. Whereas here, the embedding now got hived off from the problem. So as you'll see that gradually what we've been doing is that we've been hiving off lots of parts, so that and you put it all together. And even in MLOps, you would have seen a lot of feature calculations are hived off in a separate feature store, and you are able to do lots of things accordingly. So this kind of approach of modularization of parts of code, which somebody has done once and I can use it again and again, that has been the hallmark of last 15 odd years. Okay. Before that, each problem was a separate problem. In each problem, in real time, I had to do all the calculations. Okay. So if you look at CNN and RNN, one of the things that it did was that the feature calculation became automatic. And at least in the case of RNNs, if somebody has already done it, I can use it again. Okay. I'll tell you how horrible life was before it. That for each problem, if you wanted to do classification like dog and cat, which one is it? For that, I would have to decide what is the right embedding, and I would have to do lots of mathematics. People were building companies by saying my way of calculating feature is better than the previous ones. Okay. So there used to be a feature called HOG, histogram of oriented gradients. Have you heard of it? An Indian guy, from Delhi, who was doing his PhD in France, he came up with this paper called HOG, histogram of oriented gradients. You can take a look at it. He became a superstar in the world of AI. Okay, and that is because his way of calculating features. Essentially, what he was doing is that he calculated he kind of broke the image into patches, and for each patch, for the colors and all that, he found a histogram, and what he did was he was calculating with angles, various angles, and he created one long feature which was similar to embedding. Right, embedding is also a long vector, right? But all the math he had to do it himself. But in embedding, we don't have to worry about the math. Somehow the network takes care of that math. Okay, so now we have, over last 10-15 years, what has happened is that we don't worry about how to calculate the features. Earlier, we had to do our own mathematics behind that. Okay, now let's come to transformers. Let's see if I have the paper in front of me. Okay, this is the original paper. This was,
This is the attention paper.
yeah, this is the attention paper. As you can see, this came in 17. Okay, and of course they come up with various versions. 23, they came up with one more version, but this is the one from 2017 onwards. This whole transformer item, and it's just a notch better than LSTMs, which is it's not sequence to sequence anymore, because we are doing a lot of calculations parallelly. Yeah, this one is free. Sorry for the okay. But in some sense, this paper has been very seminal, because just by doing something as simple as doing calculations parallelly, it's made the possibility of creating larger models. Okay, so what it does is that that paper has encoder decoder architecture, which means that I can send a bunch of sentences here. Sentences get converted into embedding, and then these embeddings are kind of done a matrix multiplication with each other, which you can do it in parallel, right? So, and that's what is called attention. Attention seems very heavy duty. Okay. All right. Okay. So attention seems very heavy duty, but essentially it's calculating a bunch of matrices by doing matrix multiplications and finding those weights. And those weights, funnily, you can do all of them parallelly. And if you have a large matrix, you can split it into smaller ones, do the calculations, and then assemble it all together. Okay, that's what is multi-headed attention. The jargon is very heavy duty, right? So it's very easy for us to get overwhelmed by it. But what it is just a matrix multiplication. Okay. The paper talks about attention. This whole thing as encoder decoder. So this is like 6 times. Same thing repeats 6 times. Okay. And the dimension they work with the dimensionality of 512, which was the length of the embedding vector. Okay, not the context, embedding vector.
The matrix. No.
Okay,
embedding.
Okay, and then there is something called positional encoding, which is like which is what is the position of the word, first, second, third, fourth? Because otherwise you're in many to many matrix calculation, you lose that information. And then in a language, that order is very important, right? So that's what they are doing. Whereas in LSTMs, the order was order in which each of those nodes did the calculation. So this is a fairly clever mechanism where you can do parallel processing and yet retain the order in some sense. Okay, this one came up with encoder and decoder. The first model, I think that was also from Google. These guys are from Google Brain, and the next model which came from actual implementation came from Google Brain. They said we'll build only this one, which is the BERT model. So BERT is encoder only. So what BERT is doing is that and this is a foundational model in the sense like BERT doesn't solve a problem. It just gets you. It builds a model which can do something, and that something is fill in the blanks really. So you give it a sentence, and then you mask a few words out of it, and you ask BERT to fill the whole thing. In the process, it's learned what is the structure of the language, and then if you have a trained BERT, on top of it, you can put a very small, multi-layer perceptron, which can do something like a classification or anything else, because it's learned the structure of the language. Foundational models do the same thing. They can, given a sentence, they can predict the next word. That is the foundational model. But your foundational model is not chat. I mean, given a question, can it give me the whole answer? For that, you need to do a little bit of extra work, which is, so there are 2-3 steps around it. So BERT is only encoder only. GPT is decoder only. Yeah.
Gamma is also encoder only, right?
Gamma 2, I don't know. I've not looked at it. But if it's a chat, then it can't be encoder only. It will be a decoder. Yeah. So why is this important for us to know? Why bother encoder or decoder and all that? Because encoder only architecture tends to be very light on your RAM. So if you're solving a problem which can be solved only by encoder, please go ahead, use BERT. There is BERT Lite, and there are lots of things. If you want to do things like language translations. You can use encoder decoder, or you can use decoder only. What is decoder only? Yeah, it has chat has to be decoder only. Yeah. So nowadays we don't see that many encoder decoder because of this whole chat thing. Because translate this sentence into French. That can be a chat problem, right? I give it a sequence of words, and then it starts producing the next words, right? But in old days it was encoder decoder because one part did the encoding in English and the other part produced the answer in some other language.
What sort of problems are still relevant if I want to go encoder only?
So
Summarization,
extractive summarization, yes.
extractive summarization,
Classification.
like entity recognition.
Sorry, entity, yes, NER. Yeah. Okay. I don't know if you have time for code walkthrough. Do we have?
We are okay.
I'll just show you a code. I'll not run. It's a very simple piece of code. You'll find it in Hugging Face. But we'll just clarify a little bit about encoder decoder. Yeah. Okay. So here, what I'm doing is I'm just installing. Maybe I have already. Let's say. It's installing.
It's already pre-run. You can just explain it.
Yeah, why don't I just explain it? Yeah.
It will take time, right?
Yeah.
It's also very blurry to read.
It's blurry, right?
You can see the font of it. Control plus should do it.
Control plus will do it.
Trying entity recognition sometime back in
Okay.
with BERT and also with simple instructions to GPT 3.5.
Sure. Did GPT give you better result? Much better, right? Yeah.
Significantly.
We were trained on such a big piece of data, That's fine. So if you were to do it on BERT, then you'll have to do a fair bit of,
I have the same thought behind the scene that I should stick to a smaller model, get faster, this is what the results are.
Yeah.
Basic entity identification, like just PII and stuff, it was doing good.
Yeah.
But the moment I went into adding my custom rules,
Yeah, you have to do that secondary training on top of it with a decent amount of data, like 5,000, 10,000, then it'll work.
then it just beats the whole process because my problem is I don't have that much data.
Correct. Yeah. Then yes. So the beauty of this GPT or anything that's trained on all of internet is that you just start using it without any.
But without prompting, it was actually not that good as BERT.
Okay.
So I had to prompt like 2-layer prompting and give it instructions, give it examples of what I'm asking. Then it was giving me good results.
Sure.
Out of the box, it wasn't very simple results.
Yeah. I'm just
So
thinking.
you have to do prompt engineering.
Yeah, we did that, and that helped improve it significantly.
Yeah. Simple things like sentiment analysis, classification, to some sense, NER also. It can do, but yeah, not a lot. Recently, we were trying to do some work which was on extracting information from an invoice, and there we were able to train BERT. Yeah, but again, these restrictions come when you have to put yourself in some client environment and say, I'm going to put this model in the client environment where you don't have the flexibility of putting a large model. Yeah. Okay. So if you want to do a simple classifier like a sentiment analysis, and I did not tell this model which model to use, right? So then Hugging Face by default picks up the model that it considers to be the best for some problem like this. And you can say this is a BERT. This is a BERT model. Yeah. This is an encoder model. Okay. But
This encoder only, decoder only still foxes me a little bit, but I need to do some thinking and research to learn that.
yeah, but you see the next one, this one is a decoder model. This is a BART. Why? Because see, I'm giving the labels on the fly.
Classification problems.
Yeah, the previous one, see, sentiment is also
Is
classification.
also a classification.
But here I'm giving these labels on the fly.
Right over there. Right, you can get it.
This is it? Yeah. Thank you. Excuse me.
Yeah. So did you get why this is a decoder? This is not trained on. See, if I have to use encoder models, then I have to, when I'm training the final bit after foundation model, I have to specify the classes. If you come up with new classes, it won't work. Here you're giving the classes on the fly. I mean, I can change this to education politics, this to news and something else, sports or something.
The zero shot classification is a part of the other one, right? That way, zero shot is not be a zero shot classification.
This is a zero shot because it's without training, so it's zero shot. That has to be trained, and somebody has trained it for us. But
Is it because of the label or is it because you specify zero shot and it's not?
yeah, so I mean, if I give labels on the fly, then it's without training, right? It's zero shot. As in, I didn't have to see in older days. If you wanted to do a classification, you had to give the labels, right? I mean, if I'm feeding an article and say, is this political news, is it sports or something else, then I had to define those labels, train the model, do back and forth and all that, and then in the inference time, it would predict only from those models that is trained on.
Why did you use decoder there? Why did you use decoder here?
Okay.
That I'm not able to understand that.
Okay. There, this whole model of this sentiment analysis, right? Somebody has taken that encoder only model and has done that. So foundation model just is a language model which tells you either fill in the blank or the next word prediction. That's it. If I have to train encoder only to do a specific task, like entity recognition or let's say sentiment analysis, then somebody would put a small multi-layer perceptron on top of it and specify the classes in which you want this model to predict, right? Somebody has done this here, which means that it's been trained only on these two ones, positive and negative. If I were to give him a model like is this, it doesn't know because it knows only these two labels.
Output. The output layer we're talking about has been trained on these two labels.
Correct. This is actually a chat. This is actually a chat. Yeah.
Are you saying that whenever we are dealing with unstructured kind of data, then we should use decoder models?
Yeah, whenever you are dealing with something which has not been trained, and then you want to just you use the decoder model. That's why GPT is so popular, because now I don't have to train. For GPT, every problem is a chat problem, whether it's a language translation problem, classification problem, extraction, summarization, everything is a chat. I'm asking an agent a question and it's generating the answers. It's not going back to my question and picking things from there. Yeah.
I think this is zero shot because in one of the webinars that we conducted, right, there was a like a discussion on zero shot, one shot, and one shot, right? So I'm actually trying to relate both of them. I think this is zero shot because we are not giving any examples to it.
That's the prompt way of doing it.
Correct.
Correct. Yeah. So this whole thing prompting is a very chat specific,
So this in a way is a prompt, but it actually
is a prompt. Yes.
This is a prompt.
Yeah.
So you can just classify that zero shot, one shot. If
it is one shot, then probably we would have given one example and said, okay, this belongs to education or politics, whatever it is.
Even in prompt, you can specify an example. So it becomes few shot.
Right, few shots.
Okay. Yeah.
Give you some context and help me relate this.
Yeah. Sure.
Some time back, we were trying to get the articles, so these are scientific publications, and know the country.
Okay.
Now, many articles don't give the country. And in the US, there are many cities that are also there in other parts of the world.
Yes.
So like Ohio has a city called Cairo.
Yeah.
Right? Now, because it was Cairo, it wouldn't pick that this is US. So it didn't look at the rest of the details. Like Ohio was mentioned.
Yeah.
The only thing is it was mentioned as OH.
Okay. Yeah.
With this approach, so we ended up having to put an additional condition. If there's a 5-digit code and if it has OH in it, it's US. But is there, a more efficient way by using either encoder or decoder that you can actually solve that problem?
Yeah, I mean, these days we solve a lot of these problems by using chat framework, which is decoder only, by using some of these RAG models, where you take snippet out of it and say, read this paragraph and answer this question.
But does it have the answer to the question is
the answer is
not that,
where the question is which country.
The complexity is, can it understand the context that Cairo in this case is not Egypt?
So it would read Ohio.
RAG will do it. RAG will do it.
These things are a lot of trial and error. but hopefully the starting point should be a decoder only with a RAG model, where you are giving a part of the, because if the document is very large, then you have to give it in parts. But if the document is small enough, then you feed the whole document and say that read this document and tell me which country the author is from or which country does this person talk about.
But we have advantage of context lens, the context window. Nowadays, a lot of some of the articles I read where the context window then have got increased. Like,
Yes.
like earlier it was very less, like 512 or 724. Now it's
Thousands.
more than that.
30,000, 40,000, yeah.
So I think you will be able to get
Yeah.
it, but there are chances of hallucination.
Yeah.
That is what I.
There is this whole thing called long former. I've not read it, but it really expands your context window for long documents.
What is called long?
Long former transformer, for long transformer. Okay, so this was the GPT-2. GPT-2 again,
This one.
Oh, okay.
okay. So the next one, as you can see, is again text generation. So we have to use the GPT. This still GPT is a smaller version of a GPT. Yeah. Okay, mask filling. Yeah, most likely Bird should do this. This is a fill in the blank problem. Yeah, so Roberta is a evolution of Bird. Yeah, so it can do. Bird is trained to do exactly this, which is fill in the blanks. Yeah. NER also, I think Bird should do it. Bird, yeah.
So this will pick up the automatically, yeah?
Yeah, I mean, you see this pipeline NER. So if I say NER, then Hugging Face is trained to pick up,
Hugging Face.
unless you give a model name. You can supply the name as well. Yeah.
So one challenge we had used BioBird. This is before GPT.
Yeah.
This is a few years back. I think before prime time.
Yeah.
BioBird failed, and not just failed miserably
Yeah.
in picking new drug names.
Okay.
So what happens is the drug name, because I come from a life sciences background. A drug name has a stem,
Mhm.
right? For example, your penicillin.
Yeah.
This LLIN is a stem,
Mm.
and then from that you can deduct
Mm.
whether this is an antibiotic.
Okay.
And BioBird, in spite of having state-of-the-art features to it,
Mm.
we put in some new drug names and it just couldn't.
Okay.
So it was trained for the full word.
Yeah, possible.
It didn't have the ability to deduce
Mm.
from stemming or any other.
Yeah. I think such models have to be. Yeah.
Did you get a chance to grab GPT after that?
Train it a bit more on that data, the other data.
We've not used BioGPT, but BioBird.
We had some good
So it is able to pick new drug names which have no
It is able to pick up SNOMED codes and all those disease codes from the corpus at least. The specific example, I'm not sure.
BioBird has a lot of versions. BioGPT has a lot of versions. So I think one of them might.
For proteins, I've seen there is one language model which does protein folding and all that. So you can. Sorry,
I think RF.
I don't remember the name, but I've recently for a client I did talk about it. Yeah.
For model project. So the model will, based on the features of the molecule, reconstruct a structure which looks like a real 3D structure of a protein in an environment, a life science environment.
Mhm.
And then it uses it as a prompt for the actual and large language model to predict better protein structures or classify things like that.
All right, I think I'll just show you this one and then stop. See, question answering. If I have to extract something from here, what is enough? Which is what is doing here. It's just looking from here. But if I have to generate a paragraph, this is not enough. Okay, so because more or less all problems can be crafted as a chat problem, more and more we are going towards GPT type of model, and that's the punt that OpenAI took very early on, that everything can be a chat problem.
But is that a valid long-term assumption?
Looks like, yeah. I
But
mean,
everything is going cat way.
yes, because they are saying everything can be done via decoder only, and this is what we are also observing.
No, I don't think so. It will fail in healthcare. Okay.
Possible.
Okay.
For like one of these tools that we use for mapping brain activity, it measures difference in potential difference in real time in your brain activity. So you can't make that a chatbot. You need some model to actually measure the potential difference to classify whether it's an epileptic seizure or whether this is part of a normal activity, something like that.
You may not need an LLM for that. It could be a simple
Yeah, some other kind of model.
model. Yeah.
Generative AI will chat mode.
Yeah, I mean, it's not a generative problem.
Not
Yeah.
chat mode.
Yeah.
Because we are talking about this, and you guys are very experts in healthcare and Gen AI. I just want to ask this question: how do you manage the hallucination in healthcare?
I've not worked on it. Yes.
So I am not, I'm not a AI expert, but the challenge is not, hallucination will happen. The challenge is the liability risk. So if you are going to put yourself as a patient, and if you are going to be told that your diagnosis is based on an AI prediction, and we will naturally then treat based on that prediction. And they give you a consent form. Are you okay with that? If the prediction is wrong, even though the probability of that going wrong might be very low, but if it is wrong, who assumes the liability? So in healthcare, the adoption is not a technology question. The adoption is more about can you, who assumes the liability if you're wrong?
Human accountability.
I use the same question in a flight. If there are now, I'm sure there are capabilities where
It's not a chat-based problem. As she rightly mentioned, it's not a basically image-based problem. Because imagine this one. What was I mean? We access when I actually has to phone information, and these kind of AI bots are actually getting implemented in that domain.
yes, true. I mean, there are a lot of opportunities. The point I'm making is the tolerance for a false negative is so low that if you end in a use case which is a very low tolerance of false negative, then you will ultimately have a human intervention. But that is the only way you can protect the life.
It has to be that way. It's just going to make it fast track and go to the probability score. Based on probability, you have to decide. So it has to at the end sign it on the
And also, I think some of the industry like finance is very regulated. Right? You cannot even fit the data together. So Bloomberg data we have, right? They are saying no, you are not supposed to fit any data in the other level. Right? You cannot even generate any recommendation out of that. So these are all compliance, I think, specific to the industry.
Healthcare data becomes very, I can see it in 20 years or so that the models that have been trained on healthcare data today will fail in many countries because healthcare data changes from country to country. So people who are from Indian descent will have an entirely different physiology of looking at culture, looking at memory, learning, growing up basically, plus the weather conditions that play in. So right now, the US is building models, but there are no Indian models for healthcare. No Chinese, maybe Chinese models for healthcare. That will come in. So consolidating all the data, all the entire human species into one model for healthcare will not work.
Where was building, you were having a health startup, right? On the health AI perspective.
Yeah, before this one, I was running a healthcare startup called healthyfly.in. We were competing with 1mg Practo. And that's how we were finding it difficult to compete with Practo and 1mg. They are highly funded. So that is why we started researching AI in around 2016 timeframe. And I was telling some people that there wasn't even any book available. So with great difficulty, I found one book by Tom Michel in Sapna bookstore in Kormangla. And it was lying in his warehouse, it was dusted. So it is one of the best books still today. If you machine learning, Tom Michel by NYU professor. So so that's how we got in AI when we were trying to disrupt healthcare marketplace with an AI-based healthcare prediction model. We did build classic machine learning. It was basic probability calculation. But that's how we got in AI.
But you getting the data from all the diagnostic people?
No, we were a marketplace.
Okay.
We were a marketplace like Practo. We were booking health packages. But then nobody was using our healthcare AI, which we built. So nobody was using it.
How were you able to get the healthcare data? Because I think
No, we didn't get data. We had one. My co-founder's sister was a dietitian. So with our help, we created our own rules. So it was rules-based AI. It was not truly AI. We didn't do much of machine learning, but anyway, there was no adoption of our product. It was called Healthyfly Bot, but we could not find product market fit. But then I got in AI and started doing AI. So thank you, Prabhash. Excellent presentation on basics. So, Prabhash is our own mentor and collaborator. And with that, we come to our next session. Thank you all once again for joining. A big crowd today, a small room, I'm sorry. So my name is Vivek. Those of you who came later, I'm the co-founder and chief data scientist with CellStrat. We have a huge community of 17,000 AI researchers. And it's all people like you who present webinars and help us grow our community. So thank you once again. And after this, our agenda is that I'll do a small demo of the work we are doing, and then I'll have my friend Joji, who's visiting us from US, introduce himself. Then we'll go to our second topic with Miss Dolcy Dhar, who's our teammate and who'll present a nice topic on graph prompting. Yeah. So any questions before we move ahead? So let me share my screen. So I just want to sort of not do a sales pitch, but just show some of the work we are doing in case you want to collaborate with us, right? So that's the goal. So we have an AI marketplace platform which is called CellStrat Hub. So if you scroll in this, you'll see lots of projects. So it's very similar to Hugging Face or GitHub kind of AI community. And our community has been adding projects. You can see the respective names of the contributors as well below the project names, right? So it's a set of Jupyter notebooks. It's an integrated MLOps platform, very similar to Hugging Face. So we do have a product vision on this. We have been slow on this slightly because Hugging Face became the dominant sort of orchestration platform for AI APIs. But we do have a plan to grow this as a generative AI developer tools platform, right? So and this is one of our products, and it's a full stack marketplace with a Jupyter notebook integrated, the ready-made AI APIs as well, right? So even now when I'm doing investor pitches, so I have two products: CellStrat Hub, AI marketplace, and ImagineView GenAI platform. So whenever I'm pitching to an investor, VC or angel investor, I find that they still want to see more of CellStrat Hub. I'm trying to show them my new GenAI product, ImagineView, but they are more fascinated by CellStrat Hub. Because this is a much more mature, much more elaborate platform. And our ImagineView is still a lighter platform. So let me show that one. So this is our new Gen AI product effort, and our product interns are working on this. So as I said, we have a community. We have level 1, level 2, level 3 interns. We have a strategic research group. We have the global AI lab community, of which many of you are members. And we find that this is a slightly lighter product, but it's quite interesting. It's a simple RAG miner, so you can upload your PDFs, PPTs, or CSV, doc, TXT, or even websites. So it can basically let you create a chat on any of this literature. It's a simple RAG miner. So we have a plan to add more sophisticated agent-based prompt engineering in this, right? So this has been our first tool in this. It's still an initial product, and we have a general virtual assistant chatbot, which is very similar to ChatGPT. I think it's a GPT-4 wrapper, so not nothing new again. And recently, we have started a healthcare AI stack, right? So we have some background in healthcare from the past also. So we have started creating a world-class healthcare search engine. So currently, it will inspect the PubMed dataset. PubMed is one of the largest sources of healthcare and pharmaceutical research papers. And this team is being led by Ms. Dolcy, who's the next presenter, right? So she was sitting there. And so here we have a big roadmap of developing generative AI for healthcare, including drug discovery or research, pharmaceutical mining, or medical analysis. So lots of use cases we want to implement here over a period of time. So this is a product portfolio. Any questions?
What is it?
So this is the whole AWS stack, and we are using GPT-4 API for most of the stuff. So for our customer projects, we use Llama or Anthropic in the private AWS cloud. But for this one, for knowledge-based miner and CellStrat, we are using GPT-4. There is nothing proprietary here, and we are disclosing to the user this data is going to OpenAI server so that they don't object to it. But in our product roadmap, we have a plan to integrate Llama 2 or Anthropic, capability so that it remains within a private cloud. Right. So, any questions about our products?
Chatbot, I think GPT-4 latency is a big issue, right?
I mean, we are using this; it works quite fine. Let's say I were to, it does take some time, So if I choose any topic, I can put any random topic, and then I can just ask questions about that topic, right? So this basically is doing semantic search on a PubMed dataset. It pulls the relevant articles, embeds them in a VVA database, and then we can chat with it. This is a classic RAG pipeline. So we are planning to do quite a bit of innovation here. So let's say I just chose diabetes as the topic, so I can ask how to cure diabetes, right? So this is our beginning of a long healthcare and pharma effort, and we hope to. So we are trying two product strategies. One is a horizontal strategy with the knowledge base or document miner for corporate sector, and the second is a healthcare vertical, because our market intelligence suggests that healthcare has very high potential for generative AI. So when I went to US in January, I was speaking to one of my mentors in Bay Area. So there also I got the feedback that I used to think that healthcare would be the last sector to be disrupted by AI. But the intelligence we are getting from market mentors is that healthcare may be one of the biggest sectors. And the bulk of the healthcare workforce do not need FDA regulation. Because I was worried everything will have to go through an FDA route. But our mentors are telling us not at all. Most of the healthcare workforce do not need FDA regulation. So I'm not expert in any of those, frankly, but we have been told that healthcare Gen AI might outshine everything else. Now that could be wrong, but that's what some of the mentors are telling us.
Those regulations come in drug discovery, and you're using actual data from companies like Pfizer or Novartis. In those cases, when the data is being transferred from the parent company, the one which is collecting the data and generating the data, so when it is transferred from there to another third-party company, then those regulations play in because a lot of personal identifiers come into picture. You need to know the age, the gender of that patient to be able to classify diseases based on their age. So those regulations do come in, but if you're working internally in your own environment and you're using open source data, so here we are only using open source AI, open source articles that are present on PubMed data. Right now, we're not going into copywriting or something. We're trying to leverage what we have at our hands to come up with something innovative so that, it makes it easier for other people to at least get it started.
So this open database that you're mentioning, that does not have the PII scrubbed out of it.
No, these are all articles. There is no PII case here. So a lot of PubMed becomes a very big research database, and approximately 36 million research papers are found on PubMed using that PubMed ID. Now, it is very difficult to store that data in-house. You need tons of storage for that and need to maintain that as well. So what we're trying to do is we're letting the user decide the topic. So we'll take only like a fraction of those papers. So if I'm searching for diabetes, the maximum number of papers the abstracts get pulled are like 15,000 or something. And it gets pulled in a text file. So it's very small amount of data which we can modify and modulate and give a very good use case to the user. So if I'm a researcher and I'm working on depression and I want to always, summarize research. I don't have time to read hundreds of papers. I want to summarize research because I have to give presentations. This becomes a very good pair that you can just type in the topic, it will do the work for you. Pull out all the data for you, relevant medical data for you, and you can just talk to it, ask the questions.
Suppose you want to build a new framework for diagnosing depression, let's say.
Okay.
So in that case, you need patient data, right?
So yeah.
Where do you get that from?
So see, right now we're not diagnosing anything. Also, you have to understand that you don't need exactly a particular person living in the world to be able to understand. So much research that we know depression presents with these symptoms. So if you find those symptoms in the document that your patient provides, you'll be able to classify based on that. Based on those symptoms.
Just wanted to add on that more on, because I work on that PubMed or all that, right? It's more of the articles based on the information of the articles. So to write that article, they would have referred the clinical trials that are happened.
Right.
So PubMed don't give any of the patient information or all that. It's just the article with, okay, out of 200 patients, 10% of the people have come through. That details are coming in the article. That would come in here. Based on that, it could summarize. Yes.
So so we do have a session by Miss Dolcy shortly. So I think at that time she can discuss the healthcare stack quite in detail. A very good session on graph prompting she will be presenting. But before that, let me also finish the things here. So this is our client project. This client is based in Austin, Texas. So we also have a consulting arm, as some of you know. So we are the development vendors, but this product is owned by our client, Age of AI Capital LLC in Austin. And I did meet them also twice in the last 2 trips. And they asked us to create an uncensored downloadable chatbot. So that this was one of the world's first chatbot which downloads on your Mac or Windows computer and runs it entirely locally. So very first thing we did was took the alpaca model, which was trained on the Llama 2 by Stanford researchers, and it was trained at a very low cost of $600. And we created a Llama 2 downloadable chatbot using the alpaca frontend on a Macintosh computer. Later on, we ported to Windows. So this product went viral because it was one of the first downloadable LLM chatbot. Then GPT-4 for all and few others have come. So they have received so far 700,000 downloads on PC and Mac. So this is a successful client implementation. It has become a reference client. Then they asked us to create, because it's a very innovative product team, they asked us to create an app store of AI models. And we created an app store of AI models, which looks like this, right? So here we are adding more and more AI models. So think of a mobile app store. Here we have created an AI app store. So they tell us add this model also, so we add that. So you can use any of these models in this platform, and just by selecting from the drop down. And of course they are charging credits. They are making good revenue on this platform now. The download version is free, and it's a very innovative team. So now they have gone ahead and done some work with blockchain also with the download P2P network. So you can see here that product mindset can lead to interesting results. They are monetizing this product quite nicely now. And recently we launched something called phone call GPT for them. So you can try it. There's a free credits. So this team keeps thinking of new product ideas, right? So I'm learning quite a bit how to think product from this particular client. And phone call GPT is very interesting. It's getting hundreds of hits every day now. Many users around the world are using it for phone call automation. So an AI voice will talk on your behalf. For example, booking a movie ticket or air ticket, or disputing your telephone bill with the telephone company. Just enter the phone number and say, pretend that you are a customer of this AT&T telecom company and you are disputing some of the charges on the bill. And it will talk in an AI robotic voice with the customer care agent of AT&T and resolve that for you. And then it will create a transcript for you. So now a lot of users around the world are trying phone call GPT, and they are doing crowdsourcing of ideas that users are telling them. So there is some educator in Malaysia who's using it for, for calling students automatically about the upcoming assignments and exams. The users are creating use cases for that.
I see one of them that they're doing is for the credit card that they are giving all these phone calls which are automated.
Robotic calls. So recently, they are using Twilio API. Twilio is the most popular phone integration API. Twilio banned their account because they are creating robotic voice.
Right.
And so they are spamming people, right?
Yeah.
So Twilio banned their account. So they were violating some Twilio's regulation. So they had to do some changes in this architecture so that Twilio will let them operate. So you have to be careful about running afoul of the regulators when you use these technologies.
Is there a GPT for conversing for an incoming call?
So now they are adding a lot of capabilities. For example, now they are giving a personal phone number on phone call GPT to every user, so you can get incoming calls. So you can basically do massive phone call workflows through phone call GPT, and their users are educating the company what workflows are possible. But users are trying it in all kinds of innovative ways. Students, teachers, lawyers, and restaurant owners, they are trying the product for different workflows. See, I'm just amazed about the product mindset of this client I have. They keep coming up with new ideas.
May I suggest $1 million idea right now on this? Can you train a model?
This is not my product.
No, but I'm suggesting an idea. Can you train a model which can help a husband win an argument against his wife?
Oh, that's not possible. No, that is not possible. You can spend $1 trillion, but you won't get there. That you can rule out. No AI, nothing can solve it. So whenever it comes to human,
AI works in predictable environment.
Yes, sir. Correct. There you go. So anyway, these are some of the things we are working on, and we have one of our partners, Miss Simi here, who's working on a chemical formulation project. Simi, if you like to tell, you can tell. Otherwise, no need, as you prefer. About your project, yeah.
So we are developing a platform for formulators. So it's a B2B platform. So most of the users are into cosmetic product development, and our goal is to give them a customized formula. So when you get into the platform and say, I want to create a shampoo, and I'm a natural-based company, so I would like to majority of the ingredients as natural. I wanted to have the formula within 15 ingredients, and let's say I want to make a claim saying that it has to reduce my hair fall. So these are some of the preferences that the formulator will enter on the platform. Based on that, we will give them ingredient suggestions. Using those ingredient suggestions, depending on the experience of the formulator, they can create the formula within 2 minutes. So typically right now, they take anywhere between 3 to 6 months to do this process. So we are trying to minimize that process. And the next step after that is to predict the success rate of the formula that they have created, which will help them to decide which formula should go for lab trials. So the trial period we aim to reduce by half. So with the prediction, they should be able to do that.
So this is AI-based recommender.
Yes.
So we are using AI to recommend a set of ingredients towards a new moisturizer, towards a new lotion or whatnot. The same technique can apply for food and drug discovery as well, correct? So
how will the trial be formula recommendation you can do to the people?
So we have.
You are working Shavati, yeah.
One is.
Same stuff.
Analyze the structure of the model.
But they are doing
And then
makeup
we
formulation.
see what are the choices that we have introduced to the program, which the answers we don't know. Based on that, we have a, I'm not from the tech background, so we have a method with AI and with some of the rules that we have placed. So with that, we predict the rate, success rate. So anything below 50%, we would say, don't go ahead and try it. Anything above 50%, we should do it.
Okay, thank you for that, Sydney. And so now I invite, so Joji, you want to introduce yourself? So Joji Mon is based in California. He is our mentor from there. And Joji, you want to just introduce and what you do? That's all. Brief.
Sit and
Please do that.
He says I'm a mentor, but I don't know who mentors him. So it's actually a writing session. So I just came to Athens to see the community, like because I have known him for a few years through a mutual friend. So I came to just see how the community is and how all these meetups are going. So he told me like I have to introduce and then talk about what I'm working on. So I work as a lead in the Intel frameworks team. So I primarily work on optimizing the models, but also I work with other teams to build models. So recently we had been exploring RAG for one is basically for code generation. So we had been using Code Llama to generate code for testing CPUs basically. So so there are standard tests which are being used for testing CPUs once they are comes out of the fab. So I've been basically working on training a RAG, building a RAG to generate code to test these CPUs. And so basically the flow is more like we have set up programs, or we build a vector database based on the code base, and then use one of the LLMs to generate code. So we have been using Code Llama for that. Second project I have been working on was something similar to what Vivek had mentioned about in terms of querying documents. So I've been working on mainly with the marketing team to generate reports based on search queries for performance, CPU performances. So this is also a RAG-based project where we use it based on the search queries, what are the websites we get. We primarily distill the data from that, build a vector database, and then use LLMs to generate reports both in terms of CSV files as well as in terms of GTPs. So those are the two projects mainly I'm working on as of now. So yeah, in general, that's a basic introduction for myself.
So if you're looking for jobs in Intel California, Joji is your man. Yeah, you can talk to him.
Yeah. Yankee, go back, but take me home with you.
Okay.
Yeah, it's pretty good actually, but I think we have to do some fine tuning for these sort of tasks because it's more like CPU testing is not like just normal programs where, for example, let's say you want to test floating point accuracy, right? So you multiply numbers multiple times, then your accuracy may reduce. So those scenarios you need to test with specific type of code. So the problem is more like you give a prompt for generating the type of programs that you want, and you specify the architectures if you are specific, and then the LLM should be able to generate the code for it.
Okay. Thank you, Joji. Appreciate that. So let's get going with our next session. We'll be ordering some chai and all shortly, but let's get started with our next session. Any questions before we continue?
Can we also have coffee instead of chai?
Yes, yes. No, I mean,
That's a good question.
there is a coffee station outside, but I am not sure if it will be open. Is it open? So you may want to just quickly grab your coffee. There's a coffee dispenser station,
Yeah.
right?
If
So
you'll wait for us, only then.
yes, yes, we'll wait.
Then I'm getting.
Sure, please. We can take a 5-minute break. The washrooms are at the back and there's a coffee station. Hopefully still working.
So, and since you are streaming it, it will be available on your YouTube channel also?
We are recording it, yes.
Yeah, okay. I didn't sleep whole of last night. I had to finish one project.
Okay.
Just to attend meetups from
Yeah,
today morning.
yeah. So friends on the call, thank you for staying here. So we are taking a 5-minute break and we'll be back soon. So stay online. Thank you.
So I'm visible, right? I'm audible, right? If someone can confirm.
Can someone confirm? No, no, she is on.
Okay. I think, yes, got it. Yes. All right, thank you. Okay. All right. Hi, everyone. My name is Dolcy Dhar, and I'm currently working as a junior data scientist with CellStrat. So the reason why I'm heading the healthcare stack, like Sir asked, is that I was a healthcare professional for 6 years. I've done my bachelor's in neurological sciences from Christian Medical College, Vellore. So I worked in a hospital for 6 years, served during COVID, and then moved into AI. And I did my postgraduate in artificial intelligence from IIIT Delhi. I have worked with IIT Delhi, IIIT Delhi, and NIMHANS on computational neuroscience projects over the course of 2 years. And now I'm in generative AI.
So what was your profession?
I was a technologist, a neuroelectrophysiology technologist. So EEGs, EMGs, MRIs, all these things.
MRI, understood.
So MRI was a radiologic examination, but electroencephalography, any sort of electrical property measurement. So our brain, all our cells work on electricity. It's all about potential difference. So in any form, we measure that and we report diagnoses based on those measurements. So that used to be my job before I became an AI specialist. So my idea today is to talk about, I think, sir, aapka visible.
No, that's okay.
No, it's not full screen, no?
Oh. No, I am full screen. You have to go full screen.
You have to.
Hmm.
The slide needs to be full screen.
Yeah, I did that.
No, just switch the presentation.
Okay.
There's a presentation mode, yeah. Nice. Bottom right.
Nee, I was trying that.
नहीं, ये है ना, this-
I was trying this.
ये नहीं हो रहा? This one.
Sir, I think आपका screen shared है कि नहीं मेरा ही है.
And you can right click करो उस पर. Presentation mode आ
Why
रहा
is
है.
it not going?
Should I rejoin?
No, wait. Go to slideshow. Monitor.
Primary monitor.
Yeah, select primary maybe.
Now if I try.
Do full screen. Now the presenter view is swapped.
Should I, one second, I'll rejoin.
Maybe you rejoin.
1 minute.
Oh, PowerPoint की problem.
Technical developers also face a lot of technical difficulties. So I'm really sorry for the technical glitch.
We understand.
It seems to be a neurological.
Yes, yes. Okay. Hopefully this will work now. Yeah.
Yeah, now it's okay.
Now it's working. So I just want to give a disclaimer before we start the session that I'm very new compared to all the mentors that are sitting over here. So if I, make a mistake, please excuse me. And I don't have a working code on this topic today. I tried a lot to get the repos ironed out, but this is a very new area. So graph prompting has not been explored at all. Very less number of people are working into it because a lot of other, complications come in like storage, compute. Plus, there's one more thing that I want to mention here is that you can't do graph prompting cross domain that easily. So the knowledge graphs or the graphs that you build in a particular domain capture a kind of relationship in that domain. You can't put a healthcare graph into a finance department and ask it to work. So still there's a lot of resistance to this kind of techniques is what I want to mention. So before we dive deep into graph prompting per se, I wanted to showcase an example. So this is what a normal prompt looks like. Just want to tell you, this is a one-shot prompt because we have an example And we have instructions, cues, input data, and format. So you have to specify everything in a prompt for the large language model to do well, or for the large language model to understand what you're trying to build over here, or what your outcomes are. So if we move into more depth, so if I go here and tell you, the instruction part will decide what task you are trying to do. So you are a medical assistant, can be a part of a prompt. So that's an instruction to the model to assume a particular role or a persona to solve the next upcoming problems. Second becomes the context, the supporting information that we provide for our task. I want to understand what are the types of depression. If you take CellStrat example, types of depression is the query, is the question. But the data that we are pulling from PubMed becomes the context to our final LLM model. Then input data, whatever we are entering in the, suppose I want to write, I've pulled types of depression. I am writing my entire use case that I have been feeling very low, fatigue, don't feel interested in things that I used to do. So based on that information plus the context, the LLM will give us an output. Whatever output that, yes, you have depression, I think you should contact a medical professional, something like that. Now, there's another concept that I want to explain, which is known as prompt chaining. Multiple prompts in a successive model, in a successive chain. So with everything, with the first chain, we do entity. This is an example. We suppose do entity extraction. So there's a sentence over here. The new iPhone model is set to be released next month. It has been highly anticipated by Apple's fan and is expected to feature a larger screen and improved camera. So this is our text. I want to extract entities. So the first prompt would be extract entities. We'll get iPhone, we'll get product, we'll get Apple as an organization. Now the next chain, like LangChain, it makes it very easier. You just have to write chain equal to write your words in the standing lines. That's it. That's very simple. But at the background, this is what happens. The next chain, the next item in the chain would get executed, and this is how it goes on. So this is prompt chaining. All right. Wanted to bring everybody on the same page over here.
More chat history in the GPT 4.0, I think you have a chat history, right? Whatever response.
So yeah, you can integrate chat history.
Kind of put a chat history parameter.
But chaining becomes very different. There is no history per se. We can say we can add history to it.
So it is kind of same chain of thought basically.
Yeah, exactly.
Chain of thought.
Explaining the concept of what happens.
In your payload, you can pass whatever earlier response.
It says, you can. As part of history, you can pass it.
It's a chain of thought, and that linking basically.
But that's the problem, right? You run out of tokens.
Yeah.
So in this case, every time your prompt. So what we are trying to do here, we can look at prompting in multiple ways. So one way is that every time with every action, you are asking the LLM to generate a prompt. So every time you're asking the LLM to generate a prompt, it will take fresh tokens, right? If you're sending multiple inputs to the LLM and then you want the final prompt, then you will have a token problem. So here, the previous slide that I was showing, it was just an example of sending multiple inputs. So we'll be generating multiple prompts, not sending. So chaining doesn't mean that I'll send 5 together and then I want answer. We have to specify that. But in this context, there can be 2 ways. One is sending multiple inputs. Every time you send one input to LLM, get an answer, then analyze that answer, then do further processing. Or sometimes you want a final answer.
Sorry to interrupt.
No.
So you gave an example of the depression, right? So
Yeah.
Say I'm asking a question like I have I'm feeling fatigue or I'm having a depression. So the next thing is what kind of symptoms you have. Like so basically, are you feeling dizziness or are you having some kind of fever or you are behaving crazy? So that is the next set of questions. Can that be a LangChain?
So ideally, in medical diagnoses, there are multiple ways of coming at a diagnosis. So when you're looking at AI, you can have named entity recognition. So the patient comes and tells the chatbot that, I fell down. My left leg is swelling. There is a swelling on the calf of my left leg, and it's hurting also when I walk. I have radiating pain towards my hip. So these are entities in medical domain. These are symptoms that are entities that have been defined in the diagnostic manual by people who are taking care of standardizations. We can train the model to identify these entities and then decide whether it's depression or not. But that will also happen in the form of, we can implement it in the form of chaining. But what would be the components of that chain will depend on you and your use case. But LangChain makes it easier for you that you decide different elements and you just plug them in. There's a simple syntax for plugging a chain.
So basically, when you chain it, this question should be related. Right? The first question should be related. Second should be related to third. That's when
not necessarily.
Form the chain.
Not necessarily. So the previous thing, the only relation over here is the named entities that we have extracted. But extracting entities and summarizing are very different use cases in altogether sense. So you might have a workflow, and that workflow you will implement chaining. So then you will have related questions. But what if you want to do entirely two different things, two different workflows in the same, suppose you are experimenting and you want to do it in the same code. You don't want to change the code. In that way also, chaining can, provide you that extra functionality that will make it easier for you to implement it then and there itself.
So how you basically, instead of waiting for the answer for the first question, if you give the second part, like you did.
I think you will only get an option. So you decide what your computer will do. If I don't want to take an input after my first prompt is not finished, I will not give that option to take an input.
Not, I'm asking more about you just give us two set of instructions, basically.
Yeah. So you chain them together.
Yeah.
So there's a syntax.
The same way, or is it with it?
Yeah, so it'll work in a chain like a manner. It'll take the first element, execute that, then use the result from the first element to execute the second one, and so on and so forth. You define the chain.
This kind of autonomous agent which will.
So yeah, agents are, there are agents also which do that for you, but then you can do hard code it as well. LangChain gives you the functionality to hard code it as well. You can decide so basically when we are building our own VA model, like virtual assistants, so no need of any RAG or anything. We want a simple virtual assistant model. So in those cases, we are chaining. We send the history as part of the chain. We send follow-up questions. We also add other things. Maybe there is a pre-processing step involved. So we create those things. Varies from use case to use case. Very greatly varies from use case to use case.
So kind of a predefined tree.
Yeah. If you want, if you know, so there was this one thing that I realized while researching on this topic. When you are looking at AI now, not 10 years from, but my perspective of 2024, you need to be a domain expert. You need to know your domain inside out. Only then you'll be able to manipulate AI the way you want it to do. Otherwise, you'll always be using generic products, generic workflows. It will not work out in the long run. So graph prompting also, there was a very important thing that, domain expertise is very much needed, because in graph prompting, you specify all the rules before you start the graph prompting thing. You have to specify all the rules for every prompt. So now, even in healthcare, the prompts will change. So even if I'm looking at just text, diagnosis, prompts will change. Classification of text documents, clinical trials, whether they've passed or not, that will change. The entire workflow will change. So you'll have to redefine the graphs, redefine your prompts again and again and again. So that is one reason why this has not been, explored much. There are algorithms coming in which will make graph prompts for you automatically, but there's still a long way to go.
Basically, it's very tedious to write such.
Yes.
Right? Because there will be n number of
use cases, yes, and plus n number of rules. I am also not I have worked in healthcare, but I'm not a perfect healthcare specialist. So
neurology doctor would probably know many use cases in neurology, but would not be able to, outsource it to cardiology. So within medicine also, there's a lot of individuality coming in every department. So if you want to tackle radiology, you have to look into radiology alone. You can't think that, okay, I have data from neurology, I have data from cardiology. I can maybe augment it with text, maybe classes, labels, but ultimately you'll have to tackle the X-ray at the X-ray level. How the image is captured, what image features can be used, how we can apply, vision transformers or CNNs on top of that. So that needs to be solved. That becomes different. So now that we've come into a discussion, we understand that storage becomes a huge problem. If I talk about, because I'm from a healthcare background, one MRI image takes up about 2 GB of space. If you want to train a model on, say, 100,000 images, I don't know how many zeros will come for number of GBs that will be. Huge data storage problem is there. So AI prompting is a very good way of reducing us to, keep fine-tuning a model every time. Because our GPTs have been, like, if you take GPT or even Gemini, for example, they've been trained on huge amount of data. So they have a general knowledge. They're very good at predicting. They're very good at doing what they're doing, but we can guide them. So prompting becomes very easy. It's very easy for any of us to implement. So accuracy, you specify, like how I took you through the anatomy of a prompt. You specify the instruction, the role the AI model has to go through, and then you input the data, then decide what will be the task, and then you give an output queue. So AI prompting becomes user friendly, accurate, smart decisions. You being an expert, you don't know how to fine tune a model, but you know how to make a diagnosis. You're a doctor, you know that when a patient walks in, you examine physically, then physical examination is noted, then you look at blood tests, then that blood test values are noted, then you look at imaging. So if I feed all these 3 parameters to the large language model, will it be able to tell me? So I can make a prompt that first read the patient history, identify, extract entities from that patient history based on your previous knowledge. Second, read the radiological reports. Then finally, third, the physical examination, blood tests and all. So these are all values. Blood test concentration, HB levels are all values. Numbers are very easily manipulated. You can very easily classify. So if you augment it with text in a prompt-like format, you can actually, make it easier, make your job easier. You can make one prompt for diagnosis, and that diagnosis prompt will work for, say, a whole lot of diseases. You design it that way. Yes.
I was noting them down now.
Yeah, okay. I was just saying, so one thing would be that in healthcare, you will take 3 areas. You look at 3 areas. Physical examination, when the patient comes into your clinic. Second would be your patient history. So examination means haath uthao, lift your hand, whether the power is there or not, stuff like that. Patient history would be, when did you start coughing? What happened 2 years ago? Oh, someone was running after you with was beating you with, like, say, mummy ne mara hai, something like that. Things like that can come in patient history. And radiologic examination would be like taking X-rays, CT, MRI. If you consolidate all of that and you design a prompt to tell the LLM that, from this data, pick these informations, from this data, pick this information, and from this data, pick this information, then tell me the final answer. So it becomes easier in the form of prompt than me going and, fine-tuning one model on just physical examination, then fine-tuning second model on just patient history. That'll take a huge amount of time. Nobody wants to give you their patient history. Medical data, it's private. Nobody will sit and discuss and tell you your entire life ka medical history. Nobody will do that. People forget also. So there's a lack of data gap is there in that sense. So prompting can cover some part of it. It's not the ultimate solution, but it's better than, people like us who don't have resources at hand, and we are very good experts in our own field. So maybe we can, use prompting to come up with better solutions.
So you would have tested with large language models. So this kind of use cases where we are merging all kind of data, like
So we are actually working on it. Right now we are working on it. So we've come with CellBot. CellBot got released like a week ago. Yeah. So we hopefully soon you'll see much more functionalities coming into CellBot and other product development. So we have a product roadmap ready. We'll be working accordingly and we'll keep you updated on that. So I think AC is not.
Yeah, that we asked them that turn off AC on Saturday evening. So
Okay.
so sorry about that. So
No problem.
You can open the graph from. We'll open the door.
No, not yet. So I am looking forward to using graph prompting for CellBot.
And the like basic question, it is that AI is also coming up with prompts. Is that it, or is it more like structuring your prompts?
So I'll come to your question. So it's a very big thing. So when I start, I'll give you an example. When I started, sir asked me to present a webinar a month ago. I thought I'll give a webinar on graph prompting. Fine, it's an interesting topic, new topic, nobody has explored. Then I thought graph prompting and graph of thought is same, but it's not. Graph of thought is a part of graph prompting. So what you're trying to say, there are different frameworks to carry out graph prompting that we'll come and see as we go further in the presentation. And those frameworks will decide whether it's an LLM making the prompt or whether it's you making the prompt, how you are structuring the prompt. So different frameworks will have, so one framework has a prompting function. So it keeps prompting, just throwing prompts. Makes synthesized prompts and keeps throwing it to the element, keeps recording answers. Its job is to do that. There's another function which will just take the answers from every prompt and analyze those answers. That's it. So different frameworks as we go down.
I have a question, might be relevant for everyone. So can I use graph prompting for going through my existing code files? Basically, it's all sequential and code files are sequentially executed.
I really don't know, because it's a very big deal to implement graph prompting. So I'll tell you, I've been trying to work at a repository for the past 2 weeks, and a lot of errors. Just the workflow doesn't sit. So I don't know how much we can do it for coding and all, but I'm sure you can build knowledge graphs. So there are multiple types of graph prompting. I think one of them is knowledge graph prompting. So what you do is you take your data and you create a knowledge graph out of it, and then you use an LLM to query subgraphs. So basically, based on my input question, what are types of depression? My knowledge graph on medical data is ready in the background. Based on that depression word, it will go to that relevant node in the entire knowledge graph and then pull all its edges. All the edges will give you semantic meaning or relationships, its neighboring nodes and stuff. So from there, the LLM can, maybe pick up. So maybe for every code, there's also one more thing. Python versions change. Language versions change. So your LangChain version might be something else you're working on today. LangChain comes up with new models every week. Every week they have a new library. Old libraries are going. I don't know where it's going, but it's going. Not working anymore. So there you'll have to make a knowledge graph for every version of library that comes. So that's not feasible per se. Not very feasible. Yeah, that's taking your data and creating into a knowledge graph, no?
So actually the Neo4j, because I'm working in Neo4j, the Neo4j itself is a graph.
Yeah.
It's a kind of a knowledge
graph, yeah.
Because I will give you my use case, right? So we have a telecom data.
Okay.
So we have, see, I'll give you a very basic example. So we have location, we have multiple devices, we have shelves, cars, slots, everything, right? So all of them are into one inventory. They have been put into one inventory.
Okay.
So that itself is a knowledge graph
per se.
basically, right? So, and on top of it, you can have the prompt. Say, on this location, on this particular day, which and all devices were not working. So that I'm just
so use cases to use cases also matter. See, on X-ray images, I can't have a knowledge graph. What will I do with the knowledge graph on X-ray images, right? But it'll make more sense when we have user item interactions. So you have one kind of data So suppose like how you mentioned locations. So different locations will be different nodes. They'll be connected to subsequent nodes of different machines. So whichever machine does not light up when you're traversing the graph on that day, it will tell you that this machine is not working. It's very simple that way. But this X-ray is of plexopathy. Plexopathy is nothing but bundle of nerves getting teared. So if this X-ray is of this particular disease, graph won't work there. So again, we'll have to pick our use cases. But it's a very good way of tackling a lot of problems because human thought is not linear at all. I'm sitting over here talking about graph prompting, but in my head, I'm thinking about Mount Everest. Very easily. I want to go to those mountains, sit on the top of Mount Everest. AI cannot do that. I'll tell AI to explain about graph prompting. It won't tell me about, Mount Everest. You'll have to ask it specifically. So graph can help you model human thought much better. So that way, I'll show you further. So these are like the kind of promptings that we do. If you can see, there's a tree of thoughts, chain of thoughts, one shot, zero shot. Like we had a discussion with Prabhash sir as well on different kinds of prompts. So today we'll be exploring on graph prompting and two parts of graph prompting, which is graph of thoughts, and the other is knowledge graph prompting.
Does the axis have some?
No,
It's just
visualization. I wanted to bring some meaning to the axes, but the thoughts wala chain of thought, these things fell over. They're looking very weird, so I arranged them in a circle. No relation whatsoever. Please, these are just examples.
Lines are put to make it organized.
Yeah, it's organized. So basically, just to give an idea of core crude differentiation, this part becomes all the example-based prompts. This one becomes all chaining. These are all chaining, simple chaining, one linear path flow. This part becomes all graph prompting, graph chaining, things like that. And these are high-level, prompts. These are like information retrieval. So even RAG can also come as part of prompt engineering. If you like feed context in the prompt itself, it will come like that. And knowledge graph prompting has multiple types. So either you feed a knowledge graph or you create your own knowledge graph and then query it. So there are two types there also. So just an example, this is a zero shot prompt template. If everyone can see, there's no examples here. I won't spend time on this. And this is a few shot. So you can see two examples there on the screen. So now, most basic, we've already discussed zero shot, few shot, one shot, example-based prompting. Now these are the chain, like how I was telling you, either you trigger the LLM on every thought. So these are thought bubbles. Thought bubbles are nothing but actions for the LLM. So you can either trigger the LLM actions on every thought, or you can follow the entire workflow and get an output at the end. So this is our basic input output. You can think of it as zero shot prompt as well. These are a chain of thought that you keep a chain one, like how I was talking about prompt chaining in the beginning. So that can be an example of a chain of thought. And this is tree of thoughts. So at every junction, you decide whether you have to go left or right. But the beauty over here is that if you see these arrows, you'll understand that there's only one flow of information. There is no overlapping. You will go from this bubble either here or here. It will not be here, then back here, then here. It won't work like that. But graph prompting will change that field. So graph prompting will help you overlap. So I can reach this place from here as well and from there as well. So diabetes can have multiple symptoms. Me having fatigue probably is one symptom. I have only one half of the symptoms, but I need to reach to diabetes as the final diagnosis. But the AI wouldn't know it directly. The AI will have to take into account all the symptoms, right? That happens in computation. But here I can arrange it in such a way that multiple paths through the graph can reach a single common point. Yes.
Each nodes have good thing are all.
So this is just a diagram, just to tell you what graph of thought is. And please don't this. I only made this diagram.
But
No.
typically in the backend, some weight calculation must be done.
So I'll come to that. I'll tell you. So weight calculation will change when it comes to graphs and knowledge graphs per se. We are not looking at vector representations here. We are actually modeling exact textual relationships in the graph. So these edges that we saw might has a like textual representation directly. Doesn't have to be a number or a weight. The weights would be at the model's end when you're building a graph algorithm per se. But here we're looking at just prompting. There's no back-end thing happening. We're just designing the prompt in a beautiful way so that the LLM. Yeah, so you can like design the prompts in a chain, right? You can design so tree of thoughts is a very common prompting thing where, at every prompt, you take in the answer and you decide whether it has to go in a particular direction or not. So, like I'll explain further if you have.
Sorry.
Yeah.
So this tree of thoughts we are talking about, right? So what you feed to the LLM is the complete tree, or it's a subtree, or it can be a combination of subtree, complete tree,
Depends.
end node, leaf, everything, right? So
Yeah, that depends. That depends use case to use case.
Okay.
See, again, prompting is a user-defined thing. So you can define anyway. So people have done this. They thought, so when you look at a graph prompt, when you look at it, it doesn't look like in the shape of a graph. You don't even get the workflow directly from that graph prompt. It's just a way that how do you model human thought? So some use cases, you come like a mathematics problem, you take step by step. The first step would be add the numbers. The second step would be multiply this with this number. Third step would be this. So this is chaining. One thought, one answer. Another thought, another answer. But in graph of thought, I have multiple connections. I have maybe I have a knowledge graph, or I have a database. I want to model relationships, or like how Instagram works. It's basically a knowledge graph of all the people and their connections, their likes, their dislikes. You are connected to 100 people, so your node in the graph would have 100 connections, bilateral connections going out. So that is how you can like see, but not per se like not a physically not at the back end level. We're looking at only just asking questions, designing the prompt in such a way that we get good answers. I think someone is raising their hand.
So there is a template for prompting.
Yes.
So that if we know the well-known use cases, how we should
Ask the questions. Yeah. So kind of like chain of thought, tree of thought, and graph of thoughts are more reasoning based prompting techniques. You reason. You give the LLM the ability to reason at every step. But when you look at few shot, one shot, zero shot prompting, you're just giving them examples. You're giving them examples that study this example on your own and then build on the reasoning on your own and then give me answer. But here I'm telling the LLM, think of it in this way. You first take the first line of the problem, analyze that, then go on to the second line of the problem. You define the structure of the prompt basically that way.
So I want to go back to your first comment, which makes a lot of sense. Context, I'm a firm believer, context matters.
Matters, yes.
Right? You have to know the what before the how. Now, if you look at this tree structure, I know it's just a visual representation. Then the tree has to decide on the branch.
Yes.
There is some criteria.
Yes.
Right? Is that criteria in essence the roots?
Yes.
So is it fair to say that every such representation is unique to a given purpose or use case? Which generally then means you would create a tree, a unique tree for every use case.
Yes. So ideally, that should be done. Now, I'll tell you, to make your life more simpler, What if I divide the tree, or what if I divide that tree into actionable points? So on every node on this becomes an actionable point. Fine. So those actionable points can be cross-referenced as well. So when you come to knowledge graph, that is very domain specific. But when you're coming to what you want the LLM to do, so you will write, please extract entities. You can extract entities for multiple use cases. If you're understanding what I'm trying to say?
Yes. So for entity extraction, it makes sense. But let's take a diabetes.
Yeah, then it doesn't. You'll have to.
You have a patient, and now you need the HbA1c level to decide on which branch you need to go. Somebody then has to provide the knowledge that if it is less than 7, generally, if it is less than 7, then you're not diabetic.
Diabetic, yes.
If it's less than 6, then you're definitely not diabetic. If it's 6 to 7, it's pre-diabetic. And 7 is confirmed diabetes.
Diabetes, yes.
Right? So, is that the kind of input you would expect to decide on which branch does that knowledge graph progress?
So this will become a diagnosis use case.
Right.
So diagnosis use case across all disease diagnosis would be common. You have to understand what are the blood tests that have been fed. If I'm making sense.
Yes, you are. I mean, the point I'm trying to understand is the generality of this approach. So
not that, very honestly, in my opinion, my last 1 month of research, it's not very generalized.
It's not very, so
No.
it's very
The domain specific and very hard code heavy. So I have to sit and hard code a lot of rules in before. Then to, now they've come up with repositories, libraries, which can help you leverage automated functions. But then there's still a long way to go from generalizing graph, graph prompting per se.
But this can across use cases as well, right? Say you are doing a particular blood test. Say you are getting the cholesterol report, right? That can still be used for diabetes or for some other use cases as well, right? So we can still make it generic for some specific group of use cases.
It can. Where I'm going with this is goes back to my earlier comments. In applications where the risk of a false call, whether it's false positive or false negative, if the tolerance for a false cause is very low, I don't see any other way other than to make it very use case specific.
So there's also one more thing that we can look into it, that graph prompting, no, it's not like our normal talking with LLMs. It's not generic me sitting today and just making a prompt and talking to the LLM. These prompts actually make sense more when you're training. During the training phase, if you have a graph prompting thing, then the model learns better relationships, understands better relationships. That's what have been seen, but not a very drastic improvement, I would say. I think if I go further, yeah. 3 point. Okay.
To your point, coming back to what you're saying, right? Graph use cases generally are domain and use case specific. You can generalize to a certain extent, but beyond that, if you're looking for a very generic applicability across, it does not work. It's essentially a form of a tree like you have described, and the criticality of the use case, if your use case is very, very critical and the liability is high, then it becomes really, really purpose specific. If not, you can build some degree of generalizability. For example, like you want to do summarization across. Let's say you have 20, let's say you want to do pop health analysis. So you have 20 or 200 or 2000 different diabetes numbers across lab reports. Then you can build a graph report which gives and categorizes the reports into certain categories, saying like 80% are greater than 7, less than 7. That form of applicability can come in. But if you're looking for diagnosis, it's very, very case-based specific.
We have used the graph for real world evidence, that is how patients react when they take medicines.
Okay.
So we looked at the behavior of the whatever the data we got,
Yes.
and then put it to a
Knowledge graph, yes.
That will give us the
Exactly.
clear symptoms. That's what we have done, and this is kind of done for one of the
So graph of thoughts. So graph prompting is divided into multiple, use cases. So graph prompting is anything which involves graphs in simple terms.
One thing which I want to add.
Node, anything that we can make it as a node and
Node and edge relationship.
Nodes and
So
edge
yes,
relationship.
basically graph would make. Yeah.
One general thing which I've realized from kind of helping a friend in healthcare space. So usually when we think of graphs, we are used to thinking of free flowing the structure. What we have realized is that and that's less of a tree, more like a decision flow. What we can also do is, if there's branches which are seemingly disconnected, you can find patterns where two of these different nodes somewhere converge at the bottom, which you did not come up with originally. So for example, if you have a decision flow and you have made it in such form of a representation, it might happen that model finds a pattern which is not part of the knowledge base which you are presenting as a domain expert. So that identification of new areas is where some of these techniques helps you. But fundamentally, it just helps you in a good form of capturing information. Beyond that, what she's explaining would help you in identifying new stuff.
In a way, I think this is what new business opportunity itself. Like domain experts can build a product out of it.
Yes. So I just want to give
less coding experience.
Yeah, even with less coding experience. Yes, I'm presenting very less coding experience.
Sellability of AI.
Yes.
At the core, you can make all kinds of technical arguments. On the other side is a decision maker who has to trust that this will work for them. If and this is my real world experience. If you could say that whatever we build is designed for your unique
use case
application, it improves my faith. If you bring, when I say you, meaning anyone on the other side is making a case that the more generalizable it is, the harder it is to sell.
Yeah.
So now we are moving from generalizability to individuality. We are not at all. So people are talking about artificial general intelligence, AGI and all. We're still very far away from that. And the thing is, people don't want general stuff. I don't want what that person has. I want my own thing. Can you give me my own thing? You study me, and so our Instagram and Facebook works like that, right? It tracks our likes and dislikes and then gives us the best memes that we are looking at.
Specialized, targeted
Yes,
marketing.
exactly. So individuality is going to matter. So even when we look cross domains also, I want medicine also is now coming. They're studying more and more genetic individualities, genetic differences, so that when you walk in, and if you have Alzheimer's, we take your genetic makeup, design a drug which will cause no side effects for you, not for the rest of the world. So that is how we are moving from generalizability to individuality in this sense. And with more and more technologies coming in, see, as human beings, we're all from the same species. So we all have two eyes, one nose, one mouth. So few things can be overlapped. So general workflows can be overlapped. But ultimately, when it comes to the person in question, when it comes to that patient in question, the patient will always prefer that you're looking at me only. The doctor doesn't have to see anybody today. Only today, yes, I'll be more happy. So that is one thing, right? So last week I went with my father for his treatment to Vellore, and so many patients. The doctors are tired. It's so line, hundreds of patients are standing there. The patient is also not happy. The doctor is giving me only 5 minutes. Patient is also not happy. So we want to increase that user experience, because ultimately the doctor is not paying the hospital. The patient is paying the hospital. If you make their life simpler, and when they are in pain, when medical complications present in very different ways, so if they make their life simpler, they genuinely bless you. They genuinely say good things about you. So my college became famous because of this, because they took into account user experience and everyone. They looked at every patient as a service to the nation, as the service to God. So it's a Christian-based college. So they take it as a service and they treat everyone like that. So that is the reason why 100 years down the line, people are still going there. Nobody is going anywhere else. So that comes big factor will come in the upcoming years. So just a small brief about types of graph prompting. So graph of thoughts is nothing but like chain of thoughts. You align different reasoning modes. So you reason at every node. You decide whether you want to go left or right, and then you every step of the way you decide a question. You give an action point to the LLM, and then you proceed further. Whereas knowledge graph prompting is of two types. One is you're making your own knowledge graph and extracting information from that knowledge graph. Second is you're sending a graph thought. You're sending a knowledge graph to the LLM as a prompt, or only one specific part of that knowledge graph as a prompt. So those two use cases. Hierarchical prompting is like you divide complex tasks into subtasks. So basically you have a very big knowledge graph, you want to divide it into subsections. So I have like medical diseases ka knowledge graph, and I have one disease for neurology. So I want to capture only the neurology part. So you'll tell the LLM in such a way that you take this knowledge graph, then you identify which entity you're talking about from the first prompt, then you zero in on that, divide the task further till you find the correct answer.
Is it mic off? Somebody just said that. Your mic?
No. Mine is on.
That's fine.
Yeah, am I audible now? If someone can write it on the chat.
Yeah.
Okay.
Yeah, actually asked for the slide for GOT paper.
Okay. Good. So I want to put emphasis on one thing here, which is multimodal prompting. So multimodal prompting is also a type of graph prompting where you're giving multiple types of inputs. So you're either giving text, visual inputs like images, and like graphs also as inputs in per se. You can combine all these inputs and then send it as a prompt to the LLM. So that's also one framework that we'll be exploring today. So this is the first paper that I'm going to be talking about. This is how graph of thoughts as a framework came into picture. To model human intelligence, we needed a non-linear path. We did not need a direct path because a lot of cases are not solved by that. But these people, they tried multi-model graph prompting or multi-model way of graph of thoughts prompting, where they've taken into account text features, vision features, and the reasoning in the form of graph. So these three things were fed into different encoders. So this was fed into a text encoder, this was fed into a vision encoder, and this one was for a graph encoder. Their embeddings were combined together, and then the final prompt was generated, and then the LLM was sent the final prompt. Okay. But I want to highlight one more thing here. There's not much difference from chain of thought or tree of thoughts. We are not seeing drastic improvements. So when we go from basic input output to chain of thoughts, like how the evolution has happened, you see 15% increase in efficiency based on chain of thoughts. But when you go from chain of thoughts to tree of thoughts to algorithm of thoughts and then finally graph prompting or graph of thoughts, the change in improvement is only very minute, like 1%, 2%, 5%, not that great. So depending on what you want to achieve, it's better that you first make an analysis of whether you want to actually do graph of thoughts or will it work without that also. No need to spend so much time and energy into building a knowledge graph or at least creating a graph of thought, templates and then passing it. It will take some time and a lot of manpower and storage is required for this. So
setting aside the results that you get, this is much closer to the way human beings, think, because we think in textual, visual, and
exactly.
in this multimodal format.
Yes, multisensory.
Yeah, right.
So eventually, we need. I don't know how or when it will be possible, but if we have models which can smell, It'll be amazing. But I don't think that's possible per se now. A lot of people are working
Or at
into
least some way to represent
Present
that
the
smell.
smell,
It could be
yes.
in the form of a number also, but it.
So ultimately, you detect that smell on a sensor.
Yeah, right.
I think Sheila is already. So if you have like 70 cinemas and they throw water when the video shows water, no, we don't want that, but something similar where you have an integrated environment where you just step in and everything is taken care of. Then maybe we can think about AGI. Then, like not right now.
So this will be converted into embedding.
Yeah, in their framework, yes, they are converting into evidence. Not all everywhere you're converting it. So this is during training. So this is during training whether graph of thoughts is good for training or not, rather than fine tuning something or just using specific use cases. Can we make graph of thoughts templates that we can use for training large language models? This kind of helps them capture information from images, text, and graphs. So knowledge graphs can be relationships between images and text. Text in itself will provide a lot of information, and what the image represents or what its class is together, like how I was talking about medical diagnosis, right? Physical examination can be our physical, data fed by hand. Then patient history can also be some information. Then tables can come in for blood tests, and finally vision can come in for MRI, X-rays, those things.
We can use these as a prompts for multimodal LLMs, right? Which takes different text.
Yeah, I think right now the only repository that I came across have been using GPT-4. I've tried to run it and I managed to run the model, but there's a lot of dependency issues coming in. So not a lot of people are working in this. I only found two legit, frameworks. One was this graph of thought framework, which was a year old, and the other is a knowledge graph prompting framework that I found. Yes, sir.
Yeah. So here you're talking about at the training stage, you have 3 modes and we are playing common embedding. But let's say if you don't want to do that, is it possible to send a graph as a RAG context?
Yes, we can.
And you get an answer.
Yes. That comes in.
Yeah,
you don't need to train. So some people, it's a very unexplored area. So some people have tried graph of thoughts during, pre-training phase, and they've received much better results during the pre-training phase. But some people have created an outward library of graph of thoughts per se that you can implement and directly call an LLM in your code and send those graphs as prompts, depending on your use case. So there's a lot of overlapping knowledge. Graph prompting is an umbrella term. What you're trying to achieve would come under knowledge graph prompting, a part of graph prompting.
So I'm struggling here. Since you brought up comment about, I can understand text having features. I can understand vision having features. Graph of thought or knowledge graph is a created concept, right? It's not an innate feature of the presentation, whatever is the context or data.
But in reality, it exists, right?
So
human beings think in graph format.
Right, but it's if you're presented with a use case,
okay,
there isn't an innate representation of the graph of thought. Somebody has to go and encode, the rules or whatever is.
Yes.
So how can it be a mode? In a multimodal, text can be a mode, vision can be a mode, but graph of thought is.
So knowledge graph can be a RAG component to your mode. I have a lot of textual information. I have tons of PDFs, but transcribing every line of that PDF becomes very different. So if I make a knowledge graph out of all my PDF documents, my LLM will take care of, the model will take care of creating knowledge graph. So it will decide based on what rules you have specified, it will decide which things will go into nodes, different nodes, and which thing will be relationships. So if I take it further, so this is a knowledge graph. This is a knowledge graph of a medical use case. I'm not sure if it's clear, but anyway, this is medication. You can decide what these edges specified. But you will have to decide that as a domain expert. You can, and this as it is will be fed to the LLM, and LLM can traverse through. So there's one beautiful thing here at every node. Suppose I want to find out a disease based on a particular chemical compound. So I come to the chemical compound node, which is connected to all the chemical compounds in my data. Now my LLM is, by studying, or it's something called edge sampling. By doing edge sampling, it will study all the edges from this node. So all these edges will be studied. Based on that study, the LLM will decide which next node to traverse, to go to.
No, but we can create this knowledge graph by ingesting current medical
Yes,
literature.
we can.
Right, like Neo4j.
Yes, we can.
They will create the graph automatically.
Graph automatically for us. Yes, we can. But the problem is storing it or getting a lot of data to build these relationships. So not every kind of textual data can be converted into knowledge graph. So I can have a protein-protein interaction. I can have a list of proteins and their functions and then create a knowledge graph on that. But how will I create a knowledge graph on general knowledge? Can be anything, no? If I'm making some sense.
No,
I might be wrong,
visual
please,
helps.
sorry.
This visual helps. So once you have created this representation, then that becomes a more.
Yes. Then you can do many things. Then you can, so if I take you somewhere.
How it helps, I mean, you have three modes, right? Text, image, and the graph, right? So all these are going together.
Yes.
So from the graph, how it will help? I mean, you kind of ingested some.
So graph will
domain
give you,
knowledge.
something like that. So these people, they wanted one
I
thing.
want to understand how image, text, and graph will play together. Like once you fed into the.
So graph becomes a very good way of sampling relationships. I have a disease, I have a symptom. What is the relationship between this disease and this symptom? So when diabetes happen, blood sugar levels go high. Sugar level will be a symptom. High will be one connection. So that will come through one type of diabetes. Something like that. So that edge will give you more information between the nodes. So
No, earlier we were using graph neural networks.
Yes.
For mining graphs.
Yes.
So are you saying this technology is superior to graph neural networks?
No, that's completely different, sir. This is, I'm not going to hard code a language model here. I am just designing prompts.
I think generally this for finding the relationship between missing.
Yeah,
Yes.
prediction,
Link
node
prediction or
prediction,
node
yes.
prediction, I think. But this is kind of closer relationship.
Yes.
Okay.
Basically, if you have a knowledge graph, you can feed that knowledge graph and ask the LLM to understand or generate text. So I've come. So if you look at this picture, the thought graph over here would be all the information about a particular disease and all its relationships and different nodes connecting it. The text would be maybe the patient history. The patient has presented with so many symptoms, and the image would probably be, say, let's say a scan, an MRI scan. Now all of these three things would mean something. So based on the information from the image and the text, my LLM would know which part of the thought graph to click on and pick what relationships. So from the image, I can understand it's Alzheimer's. From the patient history also, it's looking like Alzheimer's. So what stage of Alzheimer's? You go to the thought graph, go to that node with Alzheimer's, then pull all its relationships, all the edges, and then give an answer. That looks like Alzheimer's, and this and all can be the complications. You might be at this stage, further treatment, whatever, contact, etc., can go.
From a design perspective, what is the AI component of it? Does it involve, because this is more of a conditional decision making. Right?
Yes, it's a lot of conditional decision making.
So the AI component is.
AI component is choosing at every decision. So initially you give
parsing the data, the existing data.
Parsing the actions. You have data. You have provided data. But you want the LLM to perform some actions on that data.
But we decide the edges and nodes, right?
So basically, if you feed data, not exactly manually, there's a lot of frameworks take care of that. They do real entity recognition and other steps to model graphs.
Not completely manual.
No, it's not.
No, the edges are.
Again, I'm telling you, it's a very confusing topic because even I was also very, taken to many edges of the world for this topic because there's a lot of overlapping concepts. When you think of it as a graph prompt is after the model is ready, you're sitting with ChatGPT API in your VS Code, and then you're feeding a graph prompt. That's what I'm talking about. But graph of thoughts have been used for pre-training models as well. So there, you're hard coding all the rules and relationships because you have to sell that model or to a larger audience. So changes. Now when I'm calling the chat like API, OpenAI API, and I'm sending a graph prompt, I don't want it to do extraordinary things. No, I want a simple prompt. I need to know how to design that prompt. So this is basically a structure of multiple ways you can design a prompt, a graph prompt that you can use, go home and use right away. Something like that. If I have answered your question.
I have a question.
No,
So,
sir.
say if you have a GNN can generate a graph from that, like we train a GNN to generate graph.
I think people are working now. There's one model for knowledge graph prompting as well. So basically, they've designed even one of the papers that I was looking into. It's a molecule CPT. It's a kind of a prompting function which designs graph prompts for the LLM. So its job is to design different prompts based on possible structures, protein structures. Motif is what we call those. Based on those motifs, it can suggest possible motifs, keeps on suggesting in prompts. That's its job.
Okay. So with a simple example, can you just explain the difference between a graph of thoughts being used for pre-training a model, and then after the model is ready for prompting a model? What would be the difference?
Okay. I don't think much difference except for the rules you encode. So again, graph prompting can be tackled in many ways. So one way can be that so I'll show you. This is a graph of thoughts frame code, basically syntax from the paper that I was showing you recently. So this is after the pre-trained model. Now this is what I am writing. So there are different operations. Someone has made the library, the backend, and there are different operations. So you give operations, like here we have given 5 possible generations, 5 possible answers. Then you make a score of all those 5. Then you keep the best 3. Then you explore those 3. So it will be like 5 first. Then you take 3. Then you take 1. Something like this is one form.
This you are giving as a prompt to
yes,
the
this is graph prompt, like a graph of thoughts.
Okay. So here, starting with a node and then getting all the necessary connections and relations.
Yes.
The model would know
where to go next.
Yeah, where to go next, and then based on where it arrives on the node that it arrives, finally it will fetch a corresponding answer.
Yes.
Okay.
Or will pick that node as the final answer. In case of diagonal,
the node itself can be the final answer.
Yes.
Yeah, right. Okay, that is one thing. And then when you're for the training phase, how does it work?
For the pre-training phase, so they were trying with a few short examples also. But graph, they are not like this. But I think there's a.
So this is pre-training.
No, this is post-training. I don't have the access to the code, but I did see.
But just explain the concept. Like
there's
how
not much difference. Somewhat similar only. You're giving a thought graph. So this there are 2 papers. This is one paper and this is the second paper. So the code that I showed you is of the second paper, this paper. This is graph of thoughts. After pre-training, after everything, you can call this library in your system and work on it.
Okay, so let's just say what is being trained and how is training being done when a graph of thoughts is provided as an input in the pre-training phase. That is what I'm trying to know.
I think this is the
Like we
flavor.
know in CNN, the weights are being transformed.
Yes,
Yeah,
yes,
so
yes.
here, what is changing in the training?
I am not very.
You would have the same weights here.
Yes.
So typically, in an LLM, only the language component is input text. That would go in old style LLMs. Now it's multimodal, image and text are also going.
Yes.
But with the new types of model, along with that, you are also sending one more input, which is a graph. Why graph? If you suppose you have a whole book, you can condense it in a form of a graph. Right?
Yeah, right.
And when you train it, all those things will create a bunch of weights.
Where are they being created? In the LLM itself?
Yeah, it's cross attention, after that all dots. Like green and these dots are really weights.
Okay.
It's simplified version.
Right.
It's far more complex. But let's say after it's learned all of it. After it's gone up to the decoder is giving you an answer. If you do the input, those three inputs, you'll get an answer in the form of text. Okay. Let's say you train the model. Now, for one specific case, again you say, now that you learned everything, a new patient, one image, one text, one feed all three. Right. And then you'll get an answer.
Okay. So based on the different variations of the thought graph that we are feeding, we are altering the weights of the LLM.
Yes.
Weights are trained, and then based on the inputs, we'll use those weights to create an output. Okay. During training phase,
Depends on you.
the weights
are
determined. Determined and frozen.
Right. Fine. Once they are frozen, then when I provide after it is ready and trained, when I provide a thought graph as an input, then based on those weights only, it will traverse through the graph and reach a particular node as the output.
We'll use that plus text plus image and give you a text as an answer. It's read the graph component, text component,
This is
image
just an
component,
art.
and given you a diagnosis.
Those weights which are there, that will only give the.
That will help you. Because eventually, input after encoding, everything becomes a number. It's not a picture. It's not text. It's not a graph.
So I've understood your example, but she also spoke about say, suppose let's remove the text and the image. Now we only have a thought graph as an input. She spoke about when we are using we are providing a thought graph to an already trained LLM. When it traverses through the nodes and reaches a final node, this is actually the output.
It uses that.
Yes.
Because based on some logic input, go to a particular node, and then extract some information and give you an answer.
Okay, so the node is not the final outcome. The node is again the node which it reaches is again used as an input to get a final output. That is what you say.
It depends on the.
Yeah, it depends on the use case as well. So when you're looking at a normal prompt and when you're designing a normal graph prompt, there maybe the node can be, as a precursor to the final answer that the LLM will give.
Yeah.
But when you're looking at knowledge graph, then traversing through the graph to come to a particular node will decide what your output will be.
Yeah, fair enough. Yeah. I agree with both of
Okay.
So also one question is that
Yes.
we know that the graph has a cycle. So let's say we started maybe one thought is from X-ray and another thought is coming from MRI diagnosis. So two different diverging thoughts keep on growing independently, but somehow we subsequently got one particular node which is common. The thoughts being common for MRI diagnosis that the model is going on and X-ray diagnosis. So the intersection of concept and then it takes a cycle. So how we can get rid of that?
So I think you're trying to see of the cyclic nature of graph, right? You keep coming to a single point of node again and again.
That is one. The starting point could be different. Like graph started following two different paths, but after having levels of thoughts, we come into
I come to a single node as the final answer, right? So that is actually very important in medical use cases. So multiple symptoms, multiple nodes can travel and come to the same disease, or same disease can travel and give multiple symptoms. So you can have overlapping pathways in graph, which is very useful when it comes to medical diagnoses or any kind of healthcare use case.
So in that case, the code execution point of view, how I can get rid of from that cycle. Now I can start into a cycle and how we can get out of that graph. Or
We'll
is
have
that
to specify rules and regulations to further. So then again it comes. So graph becomes a very domain specific architecture or useful method. So you'll have to figure out based on your domain how to get out of that cycle. If that makes sense.
yeah, somewhat got it.
Okay. Maybe you can reach me out and we can have a discussion
Sure,
of
sure,
this
sure.
much more
Okay.
piece. All right. So this is a second graph of thoughts, framework. So previously we were looking at multimodal graph of thoughts. These people, they have actually made something like there are two things that we need to know. One is your graph of operations. The other is your graph reasoning state. So graph of operations are these operations that you have given. So graph of operations will be predefined, user defined. So this is where your domain expertise will come in, that you are like telling the LLM how to traverse or how to walk, how to take the next steps. Whereas the graph reasoning state, I don't have a picture for that. So this graph reasoning state is the LLM's directory. It is basically large language models current information or current window where it is following a particular reasoning based on the operations that you have given. So my operations I have defined, there will be a prompter which will keep throwing those operations one after the other. The prompter will keep throwing operations to the LLM. The LLM will keep responding. The parser will decode the answer and it will send it to the graph reasoning state. It's like a working memory. So right now my task is identifying a diagnosis. So I've already given a graph of operations that you first take patient history, list all the symptoms. That is your first step. Second step, what are these symptoms? What are the common diseases that you see for these systems? These symptoms. That will become your second step. This way you give the steps. The graph reasoning state will follow the logic that you have defined in the graph of operations. And then it will give you the final output, the final answer at the end of all the steps. So here, with every operation, you are throwing a prompt to the LLM. With every task, so if I show this to you, every line over here is an action item for the LLM. If you can see operations underscore graph in this library, everything is an action item for the LLM. So for every, this is our template of a graph of operations template. We have decided this. LLM will take this template and start working on it. So one, it will take this, generate 5 answers. So basically, I fed all these symptoms, give me the 5 most common diseases. Then the next would be, fine, it is linking to 5 different diseases. Now, which of these 5 diseases are the most common 3 diseases that we can explore further? Then you would be taking those, you go in depth of those diseases to see if they're matching the symptoms, the patient history or not. And then finally, then you zero in on one. That okay, these 3 are overlapping, but this one seems the most probable one. So you're basically guiding the LLM to think in a human-like form. So it's not exactly like, LLM is doing multiple things parallelly. No, it's just thinking in a way that you are moving from one node to multiple nodes so that, you can model all those relationships effectively. Something of that sort. So I hope this is...
So LLM would be aware of the state, right? Say the initial state is you are sending the symptoms to the LLM.
Yeah.
And LLM's job is to identify those 5 diseases.
Yeah, top
right?
5 diseases.
So after it identified those 5 diseases, it is again going, it is feeding back to the response.
Yes.
At that particular state, LLM is aware of that. Now I'm at a stage that
yes.
I've already identified 5
diseases. Yes.
Right? So the next prompt is the prompt that will decide the other the block, right? That will
So-
decide the next prompt, right?
Exactly. I have already defined what will happen after the first
Five.
prompt.
Okay.
After
Okay.
the first 5 diseases are modified.
So there is no model there. So those are like hard coded.
Yeah, this is hard coded.
Yeah. got it.
You will, so graph of operations is like a predefined user template.
Got it.
To tell the LLM, you have to think in this way. Graph reasoning state becomes the LLM's mindset. So it will take the graph of operations. There's something called controller, which they have defined here. If you see, so there's a controller here, which will take in graph of operations. It will take every line from that graph of operations, then build, then do, prompting, go to the element, get answers. Based on those answers, it will do reasoning. The second step is also defined. It will go to the second step. This entire window where the LLM is, being engaged multiple times. So first answer, okay, 5 diseases have come, diabetes, hypertension, etc., etc. Now I want to go in depth. So that maintenance of the context in this case is done by your graph reasoning state, which will store from first operation to the last operation what is the reasoning flow that the LLM is going through.
Yeah, please go back to that coding part and
Yes.
decide that who run this.
We'll decide that.
The domain expert, basically.
The domain expert will decide how to model that
And
question.
this domain expert will be decide based on how you form that graph, right? So if I am in this node, what will be my action?
So this is very understandable, but you're thinking of a knowledge graph. I'm not talking about a knowledge graph. There is no knowledge graph here. This is just a method of prompting.
So is it a rule based?
Yes, it's a rule based.
It's a flowchart.
Yeah, it's a flow chart.
flowchart,
It's a flow chart.
Yeah,
Yes.
rule based, yeah.
Yeah, rule based only. It's a flow
Hard-coded
chart.
flowchart.
Yes.
Hard-coded flowchart.
But flow might use it also, right? You made a important distinction. The direction.
Yes.
This is the flow chart. The direction by the graph of operations.
Operations, yes.
Although the reasoning is done by the LLM.
Yes.
No.
So reasoning is also hard coded in these. You are deciding. So LLM is the. So how do I explain it? The LLM's task is to take every task and give the answer. That is LLM's job. But for me to get a final answer, I need to have multiple questions being answered. So when a doctor comes on to a diagnosis, it asks you many questions. But when you talk to an LLM, you are able to throw only one question at a time. If you throw multiple questions at a time, you don't usually get a good answer in a simple prompt. Here, you are telling the LLM that first take this question, give me the answer. Based on this answer, do the second question, take the second question. So first you do a physical examination, get the answers from the physical examination. Based on those answers, reason and find. We are telling the LLM here in the second line that score your answers. You score your answers and then tell us which is the most probable answer, best 3 answers that you've come with. Then you decide, then you move on to those 3, then explore every 3, one individually. Then you go further down. So this reasoning is being hard-coded by us. Thinking how you tackle these problems depends on what use case you have. So like a diagnosis problem in neurology, I can by default tell you that the first step will be a physical examination, a neurological examination. After that, the doctor will look into patient history. After that, the doctor will order tests. So I want the LLM to first look at physical examination. So I've hard-coded it.
That's basically your rule.
Yeah, that is my rule, exactly. How to reason. You're telling the LLM that reason in this way, that this is how we reason. We look at this part first, then we evaluate the answers from that part, then we go on to the second part. So the LLM can change here. If you use a medical-based LLM, every answer will be very accurate. If a medicine-based LLM is used for graph of thoughts, you'll have like a very perfect model per se. to get a diagnosis or get a final use case, like final product development value or innovation. Yes, sir. Almost done, sir.
So LLM is at the stateless, right? LLM is stateless.
Yeah.
But here, whatever knowledge is exists outside.
Yes, yes. So this is a library which is kind of like a wrapper around models. If I get some time, I'll show you the library as well. So I think I've explained a lot about knowledge graph already. Knowledge graph. So I'll move. So I don't really believe in writing a lot of text on the PPT slide, but this is very important. So I thought I'll make sure I write it. Why a knowledge graph prompting is very important and becomes so graph structure. First of all, becomes a domain specific graph structure. Structure for diagnosis, medical diagnosis might not. Please, guys, I think I'm not able to reach to the end if you can't refrain from 10 minutes. It's almost over. I promise. I'm also hungry. So, graph structure will matter from a domain perspective. So, for diagnosing diseases, probably the nodes are your diseases and symptoms and what kind of relationships those diseases and symptoms will have. That will vary. So, graph structure is very important. Will change from domain to domain. Guided traversal. So there are multiple ways of traversing a graph. There's, I think, multi-hop, and I think there's one more, dense. I'm not sure. There are two very common. Multi-hop is one of the most common ways where the LLM at every node decides whether it has to go to this node or not, which node samples all the edges, basically. Finally, yeah. So multi-hops to accumulate evidence. There's a very good thing over here. As you traverse the node in a knowledge graph, you can store the information for that node in, say, a variable. So you can store the path. So reasoning can be developed from that path, or you can guide the LLM to follow a particular path or follow a particular reasoning. So that becomes very innovative when you're taking a lot of textual data and a lot of real life experiences. You can have this to accumulate reasoning steps. So I went from, say, I fainted. Fainting is known as syncope in medical terms. So I had an episode of syncope. I want to understand what can be the causes. Is it a neurological cause or is it a cardiovascular cause? So neurological cause will explore. Then I stored the syncope as the first node. Second node will be neurological or cardiovascular. Based on the scoring, based on the patient history and other context that has been provided, my LLM will decide whether it's a neurological cause or a cardiovascular. Then it has stored. Now it has decided cardiovascular. Next step, next thought would be, now what in cardiovascular? Is it dehydration, or is it actually your heart stopping, or you having an MI, myocardial infarction, or what? Depending on that LLM, depending on the reasoning there and whatever history that we have, syncope, cardiovascular, and then those two nodes and their relationships have been stored, plus the context that we provided. Based on that, the LLM can decide whether it's a dehydration, a simple dehydration or not, or it's something else. So that's how we do context modeling, and diverse relationships is what knowledge graphs are all about. So this is just a depiction of knowledge graph prompting. So if you look at it, we are giving a question here. The question can be, write a product description for a new smartphone and explain its features. So our knowledge graph prompting would work in such a way that we've given a prompt and input. Based on this input, it will do a vector similarity search in the knowledge graph. I already have provided a knowledge graph as well. Based on what the answers would come, or the relevant information that will be extracted from the knowledge graph will then be fed to LLM as context to get the final output here in knowledge graph prompting. So benefits are that domain specific expertise can be employed. You can make an LLM, you can make a knowledge graph into your specific domain. even in your particular company. So you are working individually, you have a lot of documents, you can make a knowledge graph and talk to those documents as well. So a lot of things can be modeled in that way. And these are not vector representations alone. So eventually everything gets stored in a computational format, but here we are leveraging the semantics of the relationships. So if like how I showed you a knowledge graph where the edges were just, textual information of relationships. So that is something which we get here. We don't get that in just vector DBs. We're not able to model that in vector DBs.
Actually, the Neo4j graph Reddit but also have a similar feature
Yeah.
where the association between two nodes, right? That itself can be reported as a text.
Yes. Yeah.
Not only just one text. We
Can we have a paragraph? Yeah.
Paragraph
Also, yes. Yes, definitely. So this is one of the surveys. So I just want to touch base here. So they divided graph prompting techniques into two forms. One is discrete and one is continuous. The only difference that you need to know over here is that discrete, you don't have a continuous template, or you don't keep on sending prompts again and again and again. You integrate graph knowledge. You need to know what is your knowledge graph per se, and then make discrete prompts. So your graph should be ready before doing discrete prompting. Whereas in continuous prompting, it is not necessary to have a graph ready. You can have a template and you can keep continuously, prompting the LLM again and again and again. You can have a generic template and you can keep prompting the LLM based on that. So like how I mentioned, there was a paper called Molecular CPT, where they made a motif prompting function. So motif prompting function is nothing but molecular structure, asking the LLM to come up with different molecular structures based on some context. That's its job. It is supposed to come up with different molecular structures for the main LLM to understand whether this will actually work or not. Can this be a new drug or not? What are its interactions or not? What can be the possible features of this molecule or not? So that is something what one of the people have achieved. And this is a knowledge graph based on coagulation of blood. So what happens when you have a cut? So I wanted to give this idea. The reason why I wanted to show you this knowledge graph is that we can have multiple relationships coming in. So something is very different. So here, this is a molecule which gets stored in this structure. But that relationship is not seen over here. It's an entirely different relationship. So knowledge graph gives you the ability to model different kinds of relationships in the same graph. And you can use multiple things. So if I want to know what is the third phase of coagulation, I can just say third phase of coagulation and my LLM will go on to say platelets, and then from here it will traverse through. And as soon as it logs every node, it will keep telling me this is the first step, this is the second step, this is the third step, or third phase of coagulation. Traversing of graph can also happen here to give you answers.
So the same LLM can be used for multiple outputs.
Yes.
So, one output could be platelet, another could be what kind of drug. So
yes.
It can be same graph can be used for multiple outputs, right?
Yes. Multiple outputs, multiple inputs. So that's the reason having a knowledge graph, if you can maintain it in a storage and pay for it, again, makes a huge difference. It's best to do that. You can get relevant information right at your tips. Plus you can model, you can think in a human way. Very difficult to think in a human way, in a chain of thought or a tree of thought way. I want to go back to another, so even in diagnoses or even in medical situations and even in real life situations, you come across an experience in your life and you first compare it to the previous ones. Then you see what can be the possible changes. So this is how a human thinks. We want the AI to also think like that. For AI to learn to think like that, first we have to teach it. So there's this very big divide between old AI schoolers and new AI schoolers. Old AI people go mad that, people are just doing one prompt and getting an answer. They were hard coding all the rules, but new AI is like, we'll put Gen AI everywhere. We'll put GPT everywhere. We'll get answers. We are getting good answers because GPT, someone worked hard to hard code GPT so that it's giving us human-like information. So this can help us reach there. More human-like information, more human-like thinking actually can help us.
But the thing is, do we have enough data that medical?
Yes, we have so much. We have a lot of data. People are not leaving that data actually.
Actually, I'll just bring one further there. This in we have real evidence. This works best with even less data. And the reason is, and I have to qualify that I'm not this graph of thought expert, but the concept of rules-based approach, the power of rules-based approach works with less data. And what that means is the amount of investment. So it comes down to a business question. If the investment in data gathering and model building is very high, this is a much higher ROI. The downside of this is you will have to create a graph of thought or a representation for every use case. That's very burdensome to maintain. But if you could do that, you could literally work with a fraction, and a fraction could be 1/1,000,000th of the data set that you need for.
Because relationships don't change across data. For sequence to sequence, you have to feed a lot of data so that the model can understand what will be the next sequence. But when it comes to relationships are pretty constant. Diabetes will show you increase in blood sugar always. So if you have a framework defined,
predefined nodes.
Yes.
Nodes are like almost like chosen.
Different things for different things.
So the example I like to give is if you had a data set where it says Newton's law is wrong, Newton's law of gravity is wrong, right? And let's say you have 1 billion data points which says Newton's law of gravity is wrong, and one which says it's true, right? Your prediction is obviously going to be there is no gravity. Right now, if you have one data point which says it is true, but it is modeling a graph of thoughts, you don't need the other
data points at all.
It will always traverse the right path.
Yes. It will try to find the right node and start from there.
How about rarest to rare diseases? Right? Or maybe another thing is that whatever is maybe with our race, right? Different races, right? With the level of whatever thresholds.
So I'll go back to what you had raised early on.
I am the least person qualified to tell people to not talk. Yes.
Sorry, but I know we have very much time.
No, I just.
So by the time we are done with this, she will have old AI and new AI people.
Yes.
She's already talking about conflict in old and new AI. Yeah, continue.
So just different use cases that we can look into. So we can go with multi-modeling, text, and things. Graph prompting can find a lot of leverage. Then depending on the use case, whether it's graph level, whether you're like looking at paths, so whether you're looking at different paths from one disease to how, like from one symptom, how do you go to one diagnosis? So that will be a full model, full graph path. Whereas if you want to look at individual nodes, whether, like Steve Jobs founded Apple, so probably just Apple and Steve Jobs node, just one single edge. And if you're looking at one particular node, whether this account is malicious or not, so a lot of times we flag accounts on Instagram, whether they are malicious or not. So it will be added to that node information. So you can answer questions based on that as well. Other prompting techniques that you can explore, please after, that's all. So a joke to conclude for all of you. And that's it.
So this is a duty for me.
This is bibliography, that's it.
Okay, excellent session, Dolcy. So one thing I would like to say, bundle of knowledge, nobody is going to poach it. Otherwise, I am going to sue you. So please. So anyway, so excellent session. Thank you, Dolcy. Very well done.
Thank you, sir.
And we prompted her just like we would prompt an LLM, right? So many questions.
He gave the hints to prompt.
Yeah. I was thinking in a graph of thoughts. I hope I can run that code finally.
Thanks, Dolcy. Very well done.
No problem, sir.
So-
I'll leave this meeting.
Yeah, you can. Folks on the call, thank you for joining, and please fill this time sheet. If you have not filled, just pass it around. This attendance sheet kindly fill. And you can see good sessions here. We invite you to collaborate with our community. We have strategic research group, we have product internships, we have courses, and of course we are inviting contributors who can help us with our CellBot product stack and as well as the ImagineView product stack, right? So the ImagineView, we have a team of that, and for healthcare AI stack, Dolcy, as you said, I told, is leading our healthcare AI development stack. And nobody is going to poach her, as I've already clarified. So, okay.
If you do research, then we can.
Huh?
If you do research in that area.
Yeah, we have a research group as well.
Then we can poach her.
No, nobody knows how to poach Dolcy. Okay, so she's leading a healthcare AI stack, so you can't. So, all right. So, any questions from the audience before you all can then proceed with the chai session? And there's some snack as well. Thank you all for joining.
Thank you.
Thank you, sir, for organizing this.
Thank you, Doctor. Thanks to our two speakers, Prabhash and Dolcy. Very well. Thank you.
I don't have a time.
I'm leaving this.
I think we can say bye.
Thank you all, audience, for joining. I appreciate your attendance. Thank you.
Thanks, Vivek.
Or maybe we can-